There is a quiet truth hidden in the dark between stars. The faster we travel through space, the more silent everything becomes. Out there, motion doesn't roar, it softens, it drifts. It turns speed into stillness and distance into a slow, unfolding horizon. Tonight, we follow that silence and explore how fast humans can truly move through the cosmos. Welcome to AstraFlow. Here, science drifts like starlight, and curiosity becomes calm. Tonight, let your thoughts slow down, your breathing find its rhythm, and your mind float through wonder. Before we begin, I'd love to know where you're listening from. Are you lying in bed under city lights, or watching the stars from somewhere quiet? Tell me in the comments. It's always peaceful to imagine the AstraFlow community scattered across the world, drifting together through the same sky. And if this calm journey brings you peace, you can gently support AstraFlow by liking this video or subscribing. It helps this little corner of the cosmos keep glowing. Now, let's begin tonight's voyage into the quiet story of how fast humans can really travel through space. We start with a soft breath, a small exhale. Let your shoulders ease like a spacecraft relaxing against the stillness of orbit. There's no rush here, just the steady rhythm of your breathing, the gentle weight of your body, and the widening field of your imagination. Speed, in the universe, is not what it seems. On Earth, speed is sound. Engines humming, wheels rolling, air pushing past your skin. But beyond our atmosphere, speed becomes invisible. A spaceship could glide at tens of thousands of kilometers per hour, and inside, it would feel like a floating dream. No wind, no friction, just motion without effort. As you settle into your pillow, imagine yourself drifting through that vast star-dusted silence, held only by the embrace of gravity and momentum, the kind of place where even the fastest journey feels slow and soothing. Humans have always been mesmerized by speed, by the idea of moving farther, faster, beyond the limits of our bodies and the world we know. And yet, the deeper we explore the universe, the more we discover that speed is not loud, nor violent, nor urgent. It is gentle, soft, almost like a long inhale stretching across the dark. Tonight, we'll wander through the speeds we've reached, the speeds we dream of, and the speeds that seem impossible, at least for now. We'll drift with the spacecraft that have already left Earth behind. We'll imagine engines that whisper instead of thunder. We'll touch on the physics that governs motion and the quiet beauty of a universe where even light takes its time. But before we journey outward, breathe again. Feel the way your breath moves like a tide, flowing in, flowing out. This is your anchor as we drift deeper into the story. No urgency, no pressure to stay awake. If your eyes grow heavy, let them. If your thoughts grow soft, follow them. This is a voyage meant for both minds and dreams. And now, with your breathing steady and your body at rest, we turn gently toward our first question, the one that begins this entire exploration. What does it really mean to move fast in a universe where everything is already in motion? What does speed truly mean when the entire universe is already drifting? When every star, every planet, every grain of dust is carried along by invisible tides of gravity and cosmic expansion. As you rest here, breathing slowly, everything around you, the Earth beneath you, the sun above you, the galaxy that holds them both, is quietly moving through space. Yet you feel none of it. Motion becomes a kind of illusion, or a soft trick of perspective, shaped by what we choose to measure. Speed is never absolute. It is always relative. A comparison, a relationship, a story told between 2 points. A spaceship may glide at impossible velocity, but if everything near it drifts in the same direction, the motion begins to feel like stillness. In the calmness of space, silence becomes the soundtrack of movement, and speed becomes a whisper, not a roar. Tonight, We're asking a philosophical question wrapped in stardust. How do humans understand fast in a universe so immense that even light seems slow? Imagine standing on a shoreline at dusk. The tide pulls away, then returns, each wave moving with a purpose that feels gentle but sure. Now imagine that the shoreline itself is drifting, the entire beach carried by a current you can't see. Which motion is real? The wave? The beach? Or the hidden flow beneath them both? Human speed on Earth is like the wave. Cosmic motion is the ocean. As we drift into this thought, let your shoulders soften again. Let your breath fall into a rhythm that feels like gliding, steady, effortless. We're not searching for answers that arrive suddenly. We're letting ideas unfold, like a slow sunrise spreading across a sleeping landscape. The truth is, the universe doesn't care about fast or slow. Only humans do. We measure speed with clocks and numbers. The cosmos measures speed with patience. But even in this infinite calm, our question remains: how fast can humans really travel through space? Not just through engines and technology, but through the deep relationship between our tiny bodies and the vastness that holds them. To answer it, we'll begin gently. We'll start with what we know, the speeds we live with every day, the motions we never notice, the quiet truth that you're already travelling faster than any plane, any car, any rocket you've ever seen. You're already part of the cosmic flow. For now, simply hold the question like a small glowing ember in your palms. What does fast mean when we're already drifting through forever? To understand how fast humans can truly travel through space, we first need to rest within a simple truth. Space does not work the way Earth does. On Earth, speed is something we feel. The rumble of wheels, the push of air, the tilt of the body as velocity rises. Motion comes with friction, noise, and resistance, constant reminders that we're moving. But in space, everything is different. Out there, speed is silent, effortless, almost gentle. Imagine drifting on a calm lake. You push once with your hand, and even when you stop, the boat continues gliding. Not because you're still trying, but because nothing is slowing you down. Space is this lake stretched across infinity. No air to resist you, no surface to scrape against, just pure, uninterrupted motion. This is why the question, how fast can humans travel through space, has layers. It's not only about engines or fuel or spacecraft design. It's about understanding a place where speed behaves differently, where momentum is a quiet companion, and where the journey is shaped by distance, not friction. Let your breath settle again, smooth, unforced, as steady as a probe coasting beyond the sun. In space, 3 gentle truths define our limits. First, acceleration matters more than top speed. You can glide forever once you start, but how quickly you reach that glide depends on how gently you're pushed. Humans can only tolerate so much acceleration before the body protests. Blood shifting, organs tugging, vision narrowing. Second, energy becomes precious. To push something faster, you need more and more power. Not in a simple line, but in a steep climb. Going twice as fast takes far more than twice the energy. At high speeds, the cost becomes almost impossible. Third, distance makes speed feel small. Even at tens of thousands of kilometers per hour, the cosmos remains vast. Like walking across a continent on foot, you're moving. But the horizon barely shifts. As you breathe, imagine a small spacecraft floating in front of you. Its engines are quiet, its lights faint. Each slow burst of thrust nudges it forward, not with force, but with patience. Days turn into weeks, weeks into months. Its speed grows, not suddenly, but steadily, like a seed slowly sprouting roots in the dark. That is the rhythm of space travel. Patient, silent, shaped by the physics of a universe that favours drifting over sprinting. Tonight, we'll explore the milestones humans have reached, the rockets that carried us beyond the sky, the probes that slipped past planets, the daring machines that now travel faster than anything we have ever built. We'll look at the limits held by our bodies, our technology, and the gentle rules of relativity. And then, piece by piece, we'll trace the dream of future speeds. Solar sails, nuclear engines, even the soft imagination of near-light travel. But before we travel outward, breathe one more calm breath, in and out. Because the journey into speed begins not with motion, but with stillness. Speed on Earth feels impressive. A fast car presses your body into the seat. A jet engine hums beneath your feet as the world blurs far below. But when we lift that idea of speed into the universe, into the quiet abyss beyond our atmosphere, something strange happens. Numbers that once felt enormous begin to soften, to shrink, to lose their weight against the backdrop of cosmic distance. As you breathe gently now, imagine holding two worlds in your hands. The tiny, familiar world where a few hundred kilometers per hour feels fast, and the vast, star-filled world where even 10,000 kilometers per hour is barely a ripple. On Earth, the fastest train reaches around 600 km/h. A commercial airplane flies near 900 km/h. A rifle bullet travels over 2,000 km/h. These numbers can feel thrilling, even overwhelming, yet across the cosmos they are quiet footnotes, soft footsteps on a beach where the horizon stretches forever. To help your mind ease into this contrast, imagine a single grain of sand on your fingertip. That grain represents a human vehicle at top speed. Now imagine a desert stretching endlessly outward. That desert is the universe. Against distances measured in millions and billions of kilometers, even our sharpest sprints fade into the stillness. As you settle deeper into your pillow, imagine standing beside Earth itself. This world beneath you is spinning at about 1,600 km/h at the equator, faster than any jet, and yet you feel no wind from it, no rush of movement. Now imagine Earth orbiting the Sun at about 108,000 km/h. Again, no sensation, just a quiet ride through space. And finally, imagine the solar system drifting around the Milky Way at nearly 800,000 km/h. All of us, oceans, mountains, quiet homes, sleeping bodies, are already moving faster than any rocket humans have ever built. Yet here you are, calm and still, breathing softly in your room. This is the paradox at the heart of space travel. We're always moving faster than we think, but never as fast as we wish. Let that thought settle over you gently, like a warm blanket of perspective. When scientists talk about the speed of a spacecraft, they're not comparing it to a car or a plane. They're comparing it to Earth's orbit, the Sun's gravity, the slow drift of planets, the pull of distant stars. Space doesn't care about how fast something moves, only how far it must travel and whether it has the patience to keep going. Picture yourself floating aboard a spacecraft now. Outside the window, stars appear fixed, unmoving, as if painted on black velvet. Even if you were travelling at tens of thousands of kilometres per hour, everything would look the same. No rushing scenery, no shifting lights, just stillness. This stillness is why cosmic speed is deceptive. In the universe, speed does not feel fast, it feels like drifting, slow, quiet, effortless. And so, when we ask how fast humans can truly travel, we're also asking something deeper. How do we measure speed in a place where motion has no sound and distance has no mercy? Take another slow breath. Let your chest rise, then fall. The universe moves with you, softly, silently, endlessly. You may feel perfectly still right now, your body resting, your breath drifting softly in and out. But in this very moment, you are moving through space at extraordinary speeds, without engines, without effort, without even noticing. The universe carries you gently and constantly through an ocean of darkness and light. Let that thought settle. You are not motionless. You are part of a grand cosmic drift. Begin with the simplest motion, Earth's rotation. If you were standing at the equator, our planet would be spinning beneath you at about 1,600 kilometers per hour. That's faster than the speed of sound, faster than most bullets, faster than any race car ever built. Yet your room is quiet, your bed steady, your breath unbroken, because everything around you spins together. No wind rushing past, no sense of being flung outward, just calm, steady rotation. Let your shoulders relax with that realization. Even when you feel still, you are part of a graceful whirl across the sky. Now, lift your attention outward. Earth doesn't only spin, it orbits the Sun at about 108,000 kilometers per hour. Every second of your life, at every moment of your breathing, you are hurtling around the Sun faster than any spacecraft carrying humans has ever travelled. And yet again, it feels like nothing. No vibration, no tilt, just the quiet illusion of stillness. Imagine the Sun as a warm lantern pulling us around in a wide, elegant arc, year after year, not with force, but with gravity's gentle invitation. We follow it effortlessly, like a small boat carried by a soft current. Now drift even farther outward. The entire solar system is orbiting the centre of the Milky Way at roughly 800,000 kilometers per hour. Picture yourself gliding along a vast spiral of stars, tucked safely inside the Sun's gravitational cradle. Millions of other stars accompany you, drifting slowly like glowing embers in a dark drifting fire. And even beyond this, a motion quieter still, the Milky Way galaxy itself is moving through the universe at around 2 million kilometers per hour, carried by the deep gravitational fabric of cosmic structures far beyond our sight. All of this, while you lie here, breathing peacefully. This is the secret of cosmic motion. We're always travelling at unimaginable speeds, but motion only becomes meaningful when we measure it against something else. Your body feels still because everything near you moves with you. Your room, your belongings, the air around you, the oceans, the continents, the moon. All of us, drifting together through the night. Take a slow breath. In and out. Feel how your chest rises like a tiny wave on a vast cosmic sea. When we ask how fast humans can travel, we tend to picture rockets, engines, and spacecraft streaking across the dark. But the universe reminds us of something gentler. Speed is already woven into your existence. You do not need to try. You do not need to push. You are carried naturally, constantly, effortlessly. Your life is already a journey through space. Tonight, we'll explore the speeds we choose, the ones built by human hands, but for now, hold this quiet truth in your mind. Even in your stillness, you're moving through the cosmos at speeds beyond imagination. Long before humans ever left the ground, speed was something we could only imagine. We watched birds sweep through the sky. We watched clouds drift and storms roll. We saw comets streak overhead and wondered what it would feel like to move with that kind of freedom, not bound to Earth, but rising above it. For thousands of years, speed was a dream painted across myths, stories, and soft night skies. And then, slowly, quietly, human hands began to shape that dream. As you rest now, breathe softly, as though you're watching history unfold in slow motion. The earliest rockets were small, simple, almost fragile. Tubes filled with black powder, designed not for space but for curiosity, celebration, and war. They hissed rather than thundered, climbing only a few meters before falling back. Their speeds were not impressive by today's standards, but in their time they were tiny sparks of possibility. Imagine one of those early rockets arcing upward, leaving a brief streak of light, not fast, not high, but meaningful, a delicate beginning to a journey that would eventually reach the stars. In the early 20th century, the dream grew stronger. Rocket pioneers like Tsiolkovsky, Goddard, and Oberth imagined engines far more powerful than anything before. They wrote of liquid fuel, of staged boosters, of machines rising into the sky on pillars of flame. They saw speed not as noise and power, but as a path, a way to slip past Earth's grasp. Take a slow breath. Imagine the quiet determination of those early thinkers, a gentle vision, patiently waiting for its moment. When the first liquid-fueled rockets launched in the 1920s and 1930s, they reached speeds of just a few hundred kilometers per hour. They wobbled, sputtered, sometimes tipped over. Yet each one climbed a little higher. Each one whispered that greater speeds were possible, that the sky was not a ceiling, only a beginning. Then came the world's first true breakthrough, the V-2 rocket in the 1940s. Horrifying in its purpose, astonishing in its engineering, it reached speeds of nearly 5,700 kilometers per hour and soared through the upper layers of the atmosphere. It was the first human creation to touch the edge of space. A terrible machine, but also a turning point. Let your breath fall into an easy rhythm. History often advances through contradictions. Pain opening the door to possibility. Conflict revealing capabilities we later turn toward peace and exploration. After the war, scientists transformed rocket technology from a weapon into a vehicle for wonder. Sputnik, Laika, Gagarin, Apollo. These missions built on the speeds first reached by early rockets and pushed them farther, higher, faster, until humans finally broke free of Earth's grip. By the 1960s, rockets like the Saturn V could push spacecraft into orbit at 28,000 kilometers per hour, a speed so fast that a full lap around Earth took only 90 minutes. Imagine that. Night turning to day, then day returning to night, all in the time it takes for you to fall asleep. These speeds were unimaginable only a century earlier, yet humanity reached them by layering patience upon patience, stacking ideas, refining designs, learning through failure, listening to the quiet truths of physics. As you lie here now, breathing gently, remember that our journey into space began not with roaring engines, but with small sparks, tiny rockets rising awkwardly into the air, dreamers sketching impossible diagrams, and humanity taking its first soft steps into the sky. Speed grew from these early moments, not suddenly, not violently, but like a seed taking root, slowly gathering strength until it could reach for the stars. There is a quiet boundary around Earth, invisible, silent, always present. It's not a wall or a barrier of stone or light. It's simply gravity's embrace, a gentle pull, a constant reminder that our home planet is holding us close. To leave that embrace, to drift into true space, a spacecraft must reach something poetic in its own way. Escape velocity. Take a slow, steady breath. Feel the weight of your body on your bed. That same weight is Earth's gravity, softly anchoring you. It's the same force every rocket must overcome. Escape velocity is not a speed we maintain. It is a speed we reach, about 40,000 kilometers per hour, or 11.2 kilometers per second. A momentary burst powerful enough to break free from Earth's pull, like a bird beating its wings hard enough to rise above a thermal current. Imagine standing at the edge of a calm lake. You throw a pebble upward. It rises, then falls back. Throw it harder, and it rises higher, but still returns. Only if you throw it with incredible force does it leave your hand and never come back, slipping beyond your reach, carried by a trajectory that curves gently toward freedom. That is escape velocity. Not a roar, not a scream, just enough momentum to drift away forever. As rockets climb, they fight gravity not with anger, but with persistence. Layer by layer, stage by stage, they shed weight. They let go of what they no longer need. It's a strangely peaceful process, rising by releasing. Let your breath mirror that motion, a slow inhale and an easy exhale, letting go of tension the way a rocket lets go of empty fuel tanks. Most rockets never reach escape velocity directly. They don't leap into deep space in one motion. Instead, they enter low Earth orbit first, a gentle sideways glide around the planet. Orbit itself is a kind of cosmic balance, falling toward Earth, but moving sideways fast enough that you never hit the ground. A constant, effortless dance. Once in orbit, a small push can take a spacecraft farther, to the Moon, to Mars, or to the open dark. Just a nudge, and suddenly the destination drifts closer. Escape velocity is not a violent boundary, it's a mathematical whisper. A threshold where motion and gravity balance perfectly. A speed where Earth must finally release its grip. Imagine a spacecraft reaching that moment, engines rumbling softly through the vacuum, the curve of Earth glowing blue beneath it, clouds swirling like slow white brush strokes, and then, suddenly, the engines fall silent. The ship coasts. No more climbing, only drifting, free of the planet that raised it. This is the moment every interplanetary journey begins, when motion becomes effortless, when speed becomes silence, when the void ahead opens like a calm sea waiting to be crossed. And as you lie here, breathing gently, think of this soft truth. To travel far, we don't always need to push harder. Sometimes we simply need to reach the right moment and let go. Close your eyes for a moment and picture the moon hanging in the night sky. Calm, pale, unmoving. From Earth, it looks close enough to touch. Yet it sits nearly 400,000 kilometers away. For most of human history, that distance was an unbridgeable dream. But in the late 1960s, a handful of quiet, determined spacecraft crossed that gulf, and they did it at speeds humanity had never reached before. Let your breath slow, in and out, as we drift back to one of the most peaceful feats in human exploration. When the Saturn V rocket lifted the Apollo astronauts into space, it carried them into orbit at roughly 28,000 kilometers per hour. That speed alone is hard to grasp. Fast enough to circle Earth in just an hour and a half. Fast enough to turn continents into passing shapes beneath your feet. Yet this was only the beginning. Once Apollo was resting in the gentle cradle of orbit, a final engine burn nudged it toward the moon. This maneuver, the translunar injection, pushed the spacecraft to speeds of about 39,000 kilometers per hour. For the first time, humans drifted away from Earth not just upward, but outward, into deeper silence. Imagine sitting inside that small capsule. No roaring engines, no rattling metal, just the faint hum of life support systems. Outside the window, Earth shrinking into a fragile blue marble, suspended in an ocean of night. Even at 39,000 km/h, the journey took 3 days. That's how enormous the space between worlds truly is. A speed that on Earth would feel explosive, reckless, uncontrollable. In space becomes gentle, almost serene, like travelling through an endless dream where nothing moves except the soft arc of your trajectory. Take another slow breath. Let the pace of Apollo settle into your mind like a quiet heartbeat. During those missions, astronauts often spoke about the silence, not the dramatic, overwhelming kind, but a peaceful emptiness. Time seemed to stretch. The cabin seemed still. The sense of speed disappeared, because in space, speed doesn't feel fast. Without air rushing past, without scenery flowing by, Even tens of thousands of kilometers per hour can feel like floating in a warm, still lake at night. Apollo spacecraft carried humans farther than anyone had ever travelled. They traced arcs through gravitational fields, coasted through long periods of quiet, and relied on a balance of precision and patience rather than raw power. Their motion was almost meditative, drifting through the void with just enough velocity to reach a distant world. And when they returned home, re-entering Earth's atmosphere, they reached speeds of nearly 40,000 km/h, making them the fastest humans have ever been. Fast enough to compress air into glowing plasma, fast enough to light the sky with their descent, fast enough that the difference between survival and disaster was measured in angles of a single degree. Yet despite this intensity, their journey, from launch to landing, was shaped more by calmness than chaos, by drifting rather than racing, by coasting rather than sprinting. As you breathe gently now, imagine yourself aboard Apollo, looking out at the moon drawing closer, glowing like a lantern in the dark. Your speed is enormous. Your journey is vast. But the motion feels like a quiet wave carrying you toward a distant shore. This is the paradox of space travel. Even our greatest speeds feel soft, slow, and deeply peaceful when surrounded by the silence of the cosmos. Far beyond the orbits of the planets, farther than any spacecraft built by human hands was ever meant to travel, two small probes continue to drift through the quiet dark. Voyager 1 and Voyager 2, twin emissaries of Curiosity, have been sailing away from the Sun since the late 1970s. And though their speeds are enormous by earthly standards, their journeys feel like gentle, endless glides through a cosmic sea. Take a slow breath, in and out, as we follow these travellers into the deep. When Voyager 1 slingshotted past Jupiter and Saturn, it gained momentum from their gravity, a cosmic tug, a gracious gift of speed. Today, it coasts through interstellar space at about 61,000 kilometers per hour. Voyager 2 follows at a slightly slower pace, still exploring, still listening, still sending faint whispers of data back to Earth. On Earth, 61,000 km/h would be unimaginable. It's 50 times faster than a bullet, fast enough to cross from one side of Earth to the other in just minutes. Yet out in the vastness between stars, that speed feels like a slow, patient drift. At this pace, it would take Voyager tens of thousands of years just to reach the next star. Let that sink in, not as a measurement of distance, but as a feeling. Speed that is extraordinary to us becomes humble, almost shy, when placed against the scale of the galaxy. Imagine Voyager now, a small, quiet object, its golden record gleaming softly, its antenna pointed toward a pale blue dot it barely remembers. There are no engines firing, no thrusters pushing, no fuel left to burn. It simply moves forward on the momentum it gained decades ago, a timeless glide like a leaf carried by a gentle breeze across a still lake. In the silence of interstellar space, there is no air to resist it, no storms, no gravity to tug it sideways, just emptiness, a soft, nearly perfect emptiness that lets Voyager drift unbothered, unhurried, unending. The signals it sends home travel at the speed of light, yet even those take nearly a full day to reach us now. Imagine sending a whisper and waiting until tomorrow to hear its echo. That is the scale of its distance. As you relax deeper into your pillow, picture the view from Voyager's perspective. Behind it, the sun, shrinking into a faint star among billions. Ahead, a dark ocean without markers or borders, no up or down, no noise, no urgency, just motion, just drifting. Just a quiet continuation of a journey that has no need for destination. Voyager's speed is not a sprint. It is a breath. A long, low exhale that began in 1977 and will continue long after we are gone. And the most beautiful part? At its immense speed, Voyager never feels fast. Not in the way we understand it. It feels like floating, like surrendering to the natural flow of the universe, like moving forward at the pace of eternity. As you breathe softly now, remember this. To the cosmos, speed is not about rushing. It is about drifting with intention. Voyager drifts still, and in its slow, steady motion, it carries a small story of us, of our curiosity, our hope, our longing to reach beyond the horizon. There is a small spacecraft orbiting the sun right now, moving faster than anything humanity has ever built. It is not famous in the way Apollo was. It carries no humans, no cameras meant to inspire, no golden record like Voyager. And yet, in its silent journey, it has achieved something extraordinary. It has touched the edge of the sun's atmosphere, and in doing so, reached speeds that almost defy imagination. Take a slow breath, in and out, as we drift closer to this remarkable traveller. The Parker Solar Probe was launched in 2018 with a simple purpose: to study the sun up close. But up close in astronomy is never truly close. Even at its nearest point, the spacecraft remains millions of kilometres away, protected by a heat shield that glows white against temperatures that could melt metal. It circles the sun over and over, each time diving nearer, letting gravity pull it deeper into the star's embrace. And with each descent, Parker accelerates, not by firing engines, but by surrendering itself to the sun's immense gravity well. The closer it falls, the faster it moves, faster and faster and faster still. At its top speed, Parker reaches nearly 700,000 kilometers per hour. That's fast enough to travel from New York to Tokyo in less than a minute. Fast enough to circle Earth in a bit over 3 minutes. Fast enough that if you were riding inside it, the concept of speed would break into pure abstraction, numbers too large for the mind to hold. Yet Parker feels nothing. No air pushing back, no friction, no noise, just smooth, silent acceleration, like sliding down a slope made of gravity and light. As you sink deeper into the softness beneath you, imagine what Parker sees. A sun that no longer looks like a distant, comforting disk, but a colossal, roiling sphere of fire filling half the sky. Its surface is a swirling ballet of plasma. Its magnetic fields twist like glowing threads in slow motion. Its heat radiates through space like the breath of a sleeping giant. And Parker drifts through this furnace with astonishing calm. In this proximity, the spacecraft is shielded by a carbon composite heat plate, a kind of artificial shadow. Behind it, the instruments rest in near-room temperature, cooled by a simple system of water loops and radiators. This contrast, fire outside, cool serenity inside, mirrors the paradox of space travel itself. Extreme speed wrapped in complete silence. Unimaginable heat held back by delicate engineering. Chaos outside, peace within. Take another gentle breath. Imagine drifting at a speed so great that the universe blurs into subtle gradients. Where motion is no longer something you feel, but something you become. Parker Solar Probe is a reminder of what speed truly is in the cosmos. Not a burst of noise, not a violent surge. Speed in space is gravity's gift. A long descent, a peaceful fall into the deeper curves of space-time, and it teaches us something important for our journey tonight. The fastest motion humans have ever created is not outward, but inward, toward the star that warms us. We chase the sun not to escape it, but to understand it, and in that pursuit we reach velocities that bring us closer to the raw heartbeat of the universe. As you settle into your breath, slow and steady. Let Parker's journey remind you that speed does not have to feel urgent. Sometimes the greatest speed comes from simply letting go and letting gravity carry you. Speed, as we understand it on Earth, is built from sensations. Wind rushing past your skin, roads slipping beneath your feet, engines humming, vibrating, roaring. Your body leans when a vehicle turns. Your stomach lifts when you accelerate. Every part of you feels the motion. But in space, all of that disappears. Take a slow breath, in and out, and let the air settle softly in your chest. When a spacecraft glides through the vacuum, it feels no wind, hears no rushing air, experiences no friction at all. There is nothing for it to push against, nothing pushing back, nothing to tell the body, you're moving. Even at tens of thousands of kilometers per hour, the cabin remains still, quiet, almost eerily peaceful. Imagine sitting in a small boat on a perfectly calm lake at dawn. No ripples, no breeze. You push lightly with your hand, and the boat begins to drift. There's no sensation of speed, only motion without resistance. That's what space feels like. A boundless, silent lake where you glide forever after a single push. This is why an astronaut floating inside the International Space Station cannot feel that they are travelling around Earth at 28,000 kilometers per hour. They drift through the station as though in a slow, gentle dream. Their bodies float. Objects hover beside them. It feels slower than walking, slower than breathing, slower than falling asleep. Yet below them, continents blur by in minutes. Dawn becomes dusk. Cities glow, fade, return. All while the astronauts experience only calm weightlessness. Let your breath mimic that softness. A slow inhale, a long, easy exhale. You're floating, weightless in your own quiet orbit. The reason speed feels different in space comes down to three gentle truths. 1. No air means no resistance. Without friction, there's no sound, no shaking, no push against the body. Speed becomes smooth. 2. Constant freefall creates weightlessness. Your body doesn't press into a seat or floor. Without pressure, acceleration feels muted, almost invisible. 3. Vast distances remove visual cues. Stars are too far away to appear to move. Planets drift only slightly. The universe looks still, no matter how fast you travel. Imagine looking out a spacecraft window. The stars appear frozen in their places, unmoving even as you cross millions of kilometers. It's like traveling through a painting. Your speed has no canvas to draw motion on. On Earth, speed feels fast because the world rushes past you. Trees blurring, air brushing your face, scenery shifting. In space, none of that happens. The view remains steady, eternal. A kind of serene illusion, as if you're suspended in a moment that never changes. This is why astronauts describe space travel not as racing, but as drifting, floating, flowing. Even the fastest human-made object, the Parker Solar Probe, would feel like perfect stillness if you were riding inside it. At 700,000 km/h, you wouldn't feel pushed or pulled. You would simply be, moving with infinite smoothness through a silent sea of light. As you breathe gently now, imagine yourself held inside that quietness. No rush, no pressure, just pure motion without sensation. In the universe, speed is not experienced with the body. It is experienced with the mind through distance crossed, time stretched, and the soft hum of gravity guiding you. Out there, speed becomes peace, a slow exhale across the stars. Before we imagine faster and faster journeys through the cosmos, we need to pause and listen to the quiet language of the human body. The soft rhythms of blood, breath, bone, and balance. Because no matter how powerful our spacecraft become, our bodies remain delicate instruments shaped for life on Earth, not for the fierce pressures of rapid acceleration. Take a calm breath in and out, letting your body grow heavier against the bed. Acceleration, the act of changing speed, presses against us. It tugs at the blood in our veins. It shifts our organs. It stretches the threads of balance woven through our inner ears. This pressure is measured in G-forces, with 1G being the gentle pull of Earth beneath you right now. When you sit still, you feel 1G. When you ride a roller coaster, you might feel 2 or 3. Pilots in fighter jets can feel up to 9Gs, and even that requires training, techniques, and specialized suits to keep blood from pooling away from the brain. As acceleration rises, vision narrows, colors fade, a grey tunnel forms at the edges of sight. The mind floats between clarity and blackout. The heart struggles to pump upward against the invisible weight of pressure. Humans are not built for sudden intensity. We are built for gentleness. Take another slow breath, as though you're moving through honeyed air. A rocket launching astronauts into orbit does not simply go fast. It increases its speed gradually, so the crew usually experiences 3 to 4 Gs, a heavy pressure but steady enough to endure. Any more, and their bodies would protest. Any less, and the rocket would not rise fast enough to escape Earth's hold. Imagine lying on your back as a giant invisible hand presses down on your chest, with your own body weight multiplied several times. Breathing becomes deeper. Muscles tighten automatically. A strange heaviness flows through your limbs. This is what astronauts feel during launch. Not pain, but presence. A dense, grounding force that reminds them of their humanity. Now imagine increasing that pressure further. 10 Gs, 15, 20. At those levels, consciousness grows fragile. The body cannot send enough blood to the brain. Thoughts dim like a fading lantern. Organs strain, bones risk damage. The body whispers, no more. And so, even though rockets can create enormous thrust, they cannot accelerate too quickly. Not because physics forbids it, but because the human body does. Space itself does not limit us. Our biology does. But there is a beautiful alternative, a gentle one. Instead of pushing humans violently into high-speed travel, scientists imagine spaceships that accelerate very slowly, perhaps only a fraction of a G, but do so continuously for weeks, months, or even years. A soft, steady push, barely noticeable, like a quiet hand at your back guiding you forward. Such a ship could eventually reach staggering speeds without harming its passengers, not through force, but through patience. As you breathe softly now, let that thought drift through you. The path to great speed may not be power, but gentleness. Humans can travel fast, incredibly fast, but only if the journey respects the fragile, dreaming bodies we carry with us. In the quiet imagination of space engineers, there exists a kind of engine that doesn't roar or tremble, doesn't shake the cabin or flood the air with thunder. Instead, it gives off a gentle blue glow, a faint whisper of charged particles drifting away. This is the ion engine, one of the softest and most graceful technologies humans have ever used to travel through space. Take a slow breath, in and out, letting your body settle into the same calm, patient rhythm as these engines. An ion engine produces almost no force compared to a rocket. If you held a sheet of paper in front of its exhaust, the thrust would barely stir it. No flames, no explosions, just particles. Ions, drifting softly into the dark. And yet this quiet machine can eventually accelerate a spacecraft to speeds far beyond what chemical rockets can reach. How? Not through power, through time. Imagine standing at the edge of a vast lake. You place your hand in the water and make the slightest push, barely a ripple, almost no movement. But if you kept that gentle push going, hour after hour, day after day, you would eventually glide across the entire lake without ever feeling the urge to rush. That is the heart of ion propulsion. Small, steady pushes that never stop. Let your breath match that steady rhythm. Soft, continuous, unhurried. When spacecraft like Deep Space One, Dawn and Bepi Colombo used ion engines, They didn't leap forward like rockets. They drifted, slowly gathering speed. For days, nothing seemed to change. For weeks, the acceleration was barely noticeable, but after months, they reached tens of thousands of kilometers per hour, faster than they could ever achieve with explosive fuel alone. Ion engines are patient teachers. They show us that speed is not always born from strength. Sometimes it grows from consistency, from persistence, from the quiet choice to continue moving, even when each step feels small. Picture a spacecraft now, far from Earth. A tiny blue glow flickers from its engines. No shaking, no sound. Just a soft wind of charged xenon atom drifted backward, giving the ship the slightest nudge forward. Day by day, the ship moves faster. Month by month, it glides deeper into the solar system. A slow inhale, a long exhale, building velocity like a heartbeat stretching into the future. Ion engines cannot lift a rocket from Earth. They are too gentle for that. But once in space, where there is no friction to slow you down, they are perfect companions. They are engines designed not for racing but for drifting toward destiny. The beauty of ion propulsion lies in its philosophy. You do not need to rush to go far, you only need to keep going. Take one more slow breath. Feel the steadiness of it, the ease. That's the same simplicity that lets an ion engine carry a spacecraft across millions of kilometers. And as you rest here, drifting inside this story, remember, great speed can be born from the gentlest push, as long as the push never stops. In the quiet corners of human imagination, the places where engineers dream and physicists sketch soft lines across notebooks, there exists a different kind of cosmic engine. Not one fueled by fire or by ions drifting like blue mist, but by something deeper, older, and almost star-like, nuclear propulsion. Take a gentle breath, in and out, letting your mind open like a slowly unfolding horizon. Nuclear propulsion comes in two main forms, each with its own quiet philosophy. 1. Nuclear thermal propulsion, riding on heated lightness. Imagine a small controlled star inside a spacecraft, a warm glowing core where hydrogen flows across a nuclear reactor. The reactor heats the hydrogen until it becomes a rushing wave of superheated gas which then escapes through a nozzle pushing the ship forward. There is no explosion, no violent roar, just heat, pure, immense, concentrated heat, turning cold hydrogen into a warm breath of motion. Nuclear thermal engines could reach twice the efficiency of chemical rockets. They would not leap violently from world to world, but glide with strength and steadiness, like a warm breeze rising from desert sand at dawn. Picture a long, slender spacecraft coasting through the dark, its reactor glowing like a muted ember, pushing it forward not with explosions but with warmth. Let your breath mirror that warmth now, slow, even, glowing softly in your chest. 2. Nuclear pulse propulsion, riding the shock waves of tiny suns. The second idea is stranger, almost mythical. Project Orion, a spacecraft propelled by small nuclear detonations behind it. Tiny stars igniting in sequence, each one creating a gentle push. Boom, drift, boom, drift. Like tapping the universe's shoulder over and over, asking for another step forward. It sounds violent, but the rhythm is surprisingly poetic. A repeating pulse, a heartbeat of light. Each burst sending the ship a little farther. With systems like Orion, humans could theoretically reach speeds of tens of thousands of kilometers per hour, even hundreds of thousands, enough to cross planetary distances with quiet confidence. Imagine watching these soft bursts from afar, like slow-motion fireworks blossoming behind a drifting ship, each one illuminating the dark for just a heartbeat. Your breath rises and falls, as though matching that distant rhythm. The philosophy behind nuclear propulsion. Nuclear engines ask us to travel not with brute force, but with deeper energy. The same power that warms the sun and fuels the stars. They remind us that speed does not always come from pushing harder, but from tapping into fundamental truths written in the universe itself. But these technologies remain mostly dreams. Not because they are impossible, but because they require care, restraint, and wisdom. The cosmos invites us forward gently, and we must move just as gently in return. Still, nuclear propulsion offers a glimpse of a future where humans drift between planets with quiet strength. Not racing, not rushing, but gliding on waves of energy as old as creation. As you breathe softly now, picture a ship moving through deep space, its reactor humming like a distant lullaby, carrying travellers across the dark with patient confidence, not rushing, not forcing, just following the warm current of its nuclear heart. Speed born from stillness, motion born from the heart of stars. There is a kind of travel so gentle, so quiet, so effortless, that it almost sounds like fantasy. A way of moving through the cosmos not by burning fuel or igniting engines, but by opening a thin, shimmering sail and letting sunlight push you across the dark. This is the dream of solar sails, a technology that transforms rays of light into a silent wind. Take a slow breath, in and out, and imagine yourself drifting on that wind of light. A solar sail is astonishingly simple. It is a wide, delicate sheet of reflective material, thinner than a human hair, lighter than tissue paper. When particles of sunlight strike it, they bounce off, each one giving the sail the tiniest push. So tiny that you would never feel it. So soft that a piece of paper would not bend under it. But in the vacuum of space, with no air to slow you down, even a faint push can become a journey. Imagine placing a single finger on a small boat and pushing gently, barely any force, barely any movement. But if that gentle push continued for hours, then days, then months, you would drift across the entire lake without ever feeling rushed. That is the magic of a solar sail. Motion born not from strength, but from patience. Let your breath settle into that patience. Smooth, steady, light. A solar sail unfolds in space like a silver flower opening its petals to the sun. No flames, no shaking metal, just a soft unfurling, the sail stretching out until its vast, delicate surface catches the faint pressure of sunlight. At first, nothing seems to happen. There is no jolt, no acceleration you can feel. The spacecraft simply begins to drift, gently, silently. But hour by hour the speed builds, day by day the momentum grows. And after months of quiet pushing, the craft can reach remarkable velocities. Unlike rockets, which burn their fuel in minutes, a solar sail never runs out of energy. The sun keeps shining, the photons keep arriving, the motion continues, endless, serene. Some missions, like Ikaro's from Japan and Lightsail 2 from the Planetary Society, have already tested this dream. Their sails shimmered in the sunlight, turning rays into motion, proving that the universe itself can be a gentle engine. Now imagine yourself aboard such a craft. You are weightless. The sail stretches out around you like a glowing silk canopy. There is no noise, only silence, deep and comforting. No rumble of acceleration, no sensation of speed, just the feeling of being carried by something ancient and natural, like a leaf riding a soft breeze. This is the philosophy of solar sailing, speed born from stillness, progress born from patience, a journey measured not in explosions but in light. And if we extend this idea further, using giant sails pushed not just by sunlight but by powerful lasers, we begin to imagine speeds that could carry a tiny probe to another star within a single human lifetime. Again, not through violence, but through softness, not through force, but through flow. Take one more slow breath. Feel the lightness in your chest. That is the same lightness that would carry a solar sail across the universe. In space, Even the faintest touch can become a journey. Even a single photon can whisper, "Go, keep going, keep drifting forward." There is a kind of propulsion so powerful, so elegant, and so mysterious that it feels almost mythic. A technology not born from fire or light or gentle ions, but from the deepest symmetry in physics, antimatter. It is the mirror of everything we know, the opposite of ordinary matter, and when the two meet, they vanish in a flash of pure energy. Take a slow, deep breath, in and out, letting the idea settle like a soft glow behind your thoughts. Antimatter is real, not science fiction, not imagination, but one of the rarest substances in the known universe. Every particle you're made of has an opposite twin, a mirror self. A proton has an antiproton, an electron has a positron. Each pair forms a kind of cosmic balance. When matter and antimatter touch, they annihilate each other completely. No leftovers, no smoke, no debris. Just energy, released with astonishing efficiency. This makes antimatter the most potent fuel known to physics. A gram of antimatter contains the energy of a nuclear bomb, not because it is dangerous on its own, but because of what happens in the dance between opposites. Let your breath soften, as though you're watching two fireflies meet in the dark, merging into a single point of light. If humans could harness antimatter safely, create it in meaningful amounts, store it without letting it touch ordinary matter, and guide its annihilations with precision, our spacecraft could reach speeds that today sound like quiet dreams. Journeying between planets would take days instead of months. Voyages to the outer solar system would become soft glides instead of decade-long drifts. Imagine a slender spacecraft drifting through the dark, guided not by loud engines but by controlled releases of energy so efficient that they feel almost magical. Each burst would be small, not explosive, like the gentle strike of a tuning fork that sends a quiet vibration through the hull, pushing the ship forward. A soft push, and then a long coast, another push, and another. Antimatter engines could one day propel us to a significant fraction of the speed of light. Not instantly, not violently, but through steady, powerful acceleration, limited only by the fragility of human bodies and the quiet rules of relativity. Imagine floating inside such a ship. No sensation of motion, no roaring engines, just the soft hum of containment fields and the occasional shimmer of annihilation energy converted into forward thrust. Your view outside would not blur. There is no air in space to streak past, but stars would slowly shift positions, light would stretch into new colours, and time itself would begin to slip into a gentle distortion as your speed increased. Take another calm breath, in and out, letting the idea of near-light speed travel drift through your mind like a quiet ripple. For now, antimatter exists only in tiny quantities created in particle accelerators, atoms held for moments, costing millions of dollars to produce. Far too rare, far too delicate, far too expensive. But the dream remains. Antimatter propulsion is not just a technology. It is a symbol, a whisper of what the universe hides within its symmetry, a reminder that the cosmos holds energies far beyond our current reach, waiting for a future where human understanding grows as softly and steadily as the expanding night. As you lie here breathing gently, imagine that future. A day when our ships ride not on explosions but on pure energy. A day when opposite forces meet, not to destroy but to move us forward. A journey powered by the quiet harmony of matter and its mirror. In the softest corners of cosmic theory, where mathematics drifts into imagination and physics brushes gently against dreams, there lies an idea that feels almost like a lullaby whispered by the universe. Wormholes, not engines, not sails, but tunnels through space-time itself, doorways that might fold distance the way you could fold a blanket across your lap. Take a slow breath, in and out, letting the shape of that thought settle like a quiet shimmer behind your eyes. A wormhole, in theory, is a bridge, a shortcut, a hidden tunnel connecting two distant points in space, or even two distant moments in time. Imagine the universe as a sheet of paper. Two stars sit at opposite edges, far apart, unreachable even at incredible speeds. But if you fold the paper gently until those edges meet, the distance between them collapses into nothing. That is the dream of a wormhole. No acceleration, no engines, no years of drifting through the dark. Just a single step across a folded piece of space-time. Let your breath soften again. Feel it like a fold in your own thoughts, a gentle bending of distance. Of course, wormholes remain entirely theoretical. They appear in equations, not in our sky. They whisper through the mathematics of Einstein's relativity, through equations that describe how gravity and time can warp, twist, and curve. Yet we have never seen a wormhole, we have never built one. We do not even know if they can exist in a stable, traversable form. But the beauty of astronomy, the beauty of science, is that imagination is allowed to wander where our technology cannot. We explore ideas not because we expect them tomorrow, but because dreaming is part of being human. Imagine yourself now at the edge of one of these hypothetical structures, a glowing ring of warped starlight, space stretching and folding like soft fabric, the stars beyond rippling as though seen through water. Your spacecraft drifts toward the entrance. No sense of speed, no rumble, just a gentle shift like stepping from warm air into cool. Inside, everything becomes quiet, quieter than space itself. Not darkness, but a kind of still glow, as if light has forgotten how to travel in a straight line. Time feels thicker here, like honey. Distances feel strange, unfamiliar. Your mind, normally anchored to straight lines and open voids, gently loosens its grip, and then, just as softly, the ship emerges on the other side, somewhere impossibly distant. A different star, a different sky. A journey that would take tens of thousands of years through normal space completed in a single calm drift. Another slow breath, letting that entire vision dissolve into the quiet inside your chest. Wormholes may never be real. They may remain poetic structures living in mathematics, not in metal. But their presence in our imagination carries meaning. They remind us that the universe is stranger, softer, more mysterious than our instincts suggest. They show us that distance itself is not as rigid as it seems, that space can bend, time can stretch, and reality has folds we do not yet understand. And perhaps, someday, far in the future, when humanity has grown patient enough, curious enough, gentle enough, we may discover that the universe offers paths not of force, but of understanding. Paths where speed is no longer about motion, but about connection, bridging the farthest corners of existence with a single quiet step. For now, wormholes remain dreams, but dreams are seeds. And in the calm soil of imagination, even the wildest ideas can take root. There is a soft, almost invisible boundary woven into the fabric of physics, a quiet rule whispered by the universe. It tells us that the faster an object moves, the heavier it becomes. Not in the way a stone feels heavy in your hand, but in a deeper, subtler sense. Its mass increases. Its resistance to acceleration grows. Every small push becomes harder. Every gain in speed demands more energy than the last. Take a slow breath, in and out, feeling the way even your own body resists movement when you're tired. The universe follows a similar rhythm. As a spacecraft approaches the speed of light, this resistance rises steeply, Like climbing a hill, it becomes steeper and steeper the higher you go. At first, the slope is gentle. Then it becomes demanding, and near the top it approaches vertical, impossible to climb with any finite effort. This is why reaching even half the speed of light demands unimaginable energy, why 90% becomes nearly unreachable, why 100%, the true speed of light, remains forbidden for anything that has mass. It is not a punishment, not a barrier made to frustrate us. It is simply the universe being consistent, the way gravity always pulls downward and waves always return to shore. Let your breath fall into that same consistency, steady, predictable, soft. Imagine pushing a sled across a frozen lake. At first it moves easily, a gentle nudge sends it gliding. But imagine that with each meter it travels, the sled becomes heavier, not suddenly but gradually. By the time it has crossed the lake, it feels as heavy as a boulder. Try pushing it again, and the effort becomes enormous. This is what happens as speed increases. Every meter per second costs more, every increment demands deeper energy. Acceleration slows, not because engines grow weaker, but because reality thickens around the object. Like moving through honey that grows denser the faster you go. Take another slow breath. Let the idea thicken and thin in your mind, just as the universe thickens around fast-moving bodies. Now imagine a spacecraft moving at 99% of light speed. Time inside the ship stretches differently. Clocks tick slowly. Your heartbeat lengthens. Your perception shifts. Space around you compresses in the direction you're travelling. The universe itself bends politely out of your way, following the rules of relativity. But the energy cost becomes staggering. To push from 99% to 99.9% of light speed, a tiny numerical increase, requires double the energy. To push further still, to 99.99%, demands double again. It is a ladder whose rungs grow farther apart with every step. The closer you get to light speed, the more the universe asks of you, gently but firmly. For humans, there is another layer. The body is fragile. Acceleration stresses organs, shifts blood, strains tissues. We cannot withstand sudden force. We can only endure gentle, gradual increases, what scientists call low-G acceleration. A soft push sustained over long spans of time. So even if a spaceship could, in theory, accelerate quickly, its human passengers could not. We are creatures of Earth, built for warmth, gravity, and slow rhythms. Take a deep breath, letting it expand your chest like a slow wave lifting toward shore. Lightspeed travel is hard, not because the universe is unkind, but because it is honest. It follows rules that make space stable, predictable, and safe for stars and planets and drifting dust. Without these rules, galaxies would tear apart, atoms would collapse, and the fabric of reality would tremble. In the gentle vastness of the cosmos, limits are not walls, they're quiet guardians. And so, when we ask why humans can't reach the speed of light, the universe answers softly, because light belongs to light, and you belong to the slower, softer currents of matter. Yet within those currents we still drift, we still explore, we still move forward, slowly, steadily, beautifully. In the softest darkness of space there is a paradox that feels almost comforting. The faster you move, the quieter everything becomes. There is no wind, no friction, no roar of air slipping past your skin, only a vast, velvety emptiness that allows motion to unfold without interruption. Take a gentle breath, in and out, letting your body settle into the same stillness that surrounds a drifting spacecraft. Space has no air to push against, no molecules to scrape along the hull, no turbulence to shake the cabin. A ship gliding through the void feels no resistance at all, not even at thousands or tens of thousands or hundreds of thousands of kilometers per hour. Speed becomes smooth, pure, almost meditative. Imagine floating through an endless underwater cavern, except the water offers no drag, no pressure, no pull. You extend your hand lightly, and your entire body drifts forward. There is no sound except your own breath. No sensation of movement except the slow shift of light across the rocks. That is what motion in space feels like. This lack of resistance is both a blessing and a challenge. A blessing. Once a spacecraft accelerates, even gently, it will continue moving forever unless something stops it. A single push can become an eternal drift, like tossing a feather in a place where it will never fall. A challenge. Because nothing slows the ship down, stopping or changing direction becomes difficult. A spacecraft cannot rely on friction to reduce its speed. It must use fuel, force, or gravity to alter its path. It must be deliberate, patient, careful. Take another slow breath, imagining yourself gliding in this perfect silence. Now picture a spacecraft crossing through the interstellar medium, a place not truly empty, but so close to emptiness that the dust grains and atoms are scattered like whispers. Even at incredible speeds, the ship slips through these particles as though through fog so thin it barely exists. Yet even this faint material carries weight. At extremely high velocities, especially near a significant fraction of the speed of light, each tiny particle becomes dangerous. A single grain of dust hitting the ship could release massive energy. A stray atom becomes a tiny bullet. A fleck of interstellar ice becomes a spark of destructive light. But at the speeds humans have reached so far, even these dangers are silent and distant. Voyager drifts untouched. Probes glide safely. Our presence in space is still gentle, still slow compared to the universe's deeper dangers. Let your breath fall into a rhythm as quiet as that drifting. As strange as it sounds, the biggest difficulty of high-speed travel isn't resistance from space. It's the lack of it. On Earth, resistance helps us. It slows us down when we stop pedaling. It keeps cars from sliding endlessly forward. It makes motion predictable. In space, there is nothing to hold on to, nothing to lean against, nothing to cradle a moving object. Speed is like holding a smooth stone on a frozen lake. Once you let it go, it will glide across the ice forever. Imagine yourself now as that stone, gliding, drifting, floating in a straight, endless line. No bump, no sound, no sensation of slowing or stopping, just the infinite comfort of uninterrupted motion. This is the silence of space resistance, a silence so complete that it becomes a kind of music, a rhythm of nothingness that lets speed unfold like a long, peaceful breath. Speed in space is silent, gentle, and free of friction, but it is never free of danger. As a spacecraft drifts faster and faster through the dark, it encounters something invisible, powerful, and always present: cosmic radiation. Take a slow breath, in and out, letting your awareness soften like a dimming lantern. Space is filled with tiny particles moving at extraordinary speeds. They come from the sun, from distant stars, from exploding supernovae. They slip through the cosmic dark like rain through fog, unseen, unannounced, unstoppable. Most are harmless in small doses, but some strike with energies so intense they can pass straight through metal and through flesh. At low speeds, this radiation flows around a spacecraft gently, like wind around a resting tree. But as speed increases, especially to a significant fraction of the speed of light, the energy of each collision rises dramatically. Imagine standing in a soft rainfall. Each droplet is tiny, harmless. You barely notice it, but now imagine running through the rain. The droplets strike harder, faster, sharper. The impact becomes more intense, not because the rain changed, but because you did. Cosmic radiation works the same way. The faster you move, the harder each particle hits. Let your breath settle. Feel the quiet truth of motion meeting energy. At near light speeds, even the smallest particle of dust becomes a projectile. A single atom of hydrogen, normally harmless, can strike a ship with enough energy to damage electronics or erode shielding. A tiny grain of interstellar dust can ignite into a flash of plasma on impact, like a miniature star erupting against the hull. This is why imagining human travel at high velocities means imagining protection, not only from the vastness of space, but from the invisible rain of particles that fills it. Take another slow breath, as though you're creating a shield of calm around your mind. Scientists have imagined many gentle solutions: thick layers of hydrogen-rich materials, magnetic shields shaped like auroras, electric fields like soft bubbles enveloping the ship. Some designs resemble delicate force fields, not aggressive but protective, like a soft shell cradling the craft. As the ship moves faster and the particles grow more energetic, the shielding must become stronger. But too much shielding adds weight. Too much weight slows the ship. Slowing the ship reduces the radiation risk, a complicated dance of balance and motion. Imagine now a spacecraft hurtling through interstellar space. Outside, particles strike the shielding like barely audible taps on a window. Inside, everything remains calm, quiet, still. The crew breathes slowly, each heartbeat steady under a blanket of artificial night. Even at high speeds, space offers a kind of grace. Radiation is not punishment. It is simply part of the cosmic environment. Like wind on Earth or waves on the ocean, it asks for respect, for patience, for protection. It reminds us that every journey, no matter how bold, carries its own risks. Take one more gentle breath. Let it flow through you like a calm shield. In the end, cosmic radiation teaches us something profound. In the universe, motion changes everything. Not just where you go, but how the universe touches you. Speed is silent, but its consequences ripple outward, shaping the way we design, dream, and travel. And still, even knowing all this, humans continue to look toward the stars. Drawn by the quiet promise that lies beyond danger, the promise of discovery, there is a gentle idea that drifts through the dreams of scientists and storytellers alike. The possibility that one day, humans might travel through deep space not awake and alert, but resting, sleeping, wrapped in a long protective slumber as their ship sails across the dark. This is the concept of human hibernation, a technology inspired by animals and imagined for journeys too long for waking life. Take a deep, slow breath, in and out, letting your body soften into the idea of deep rest. On Earth, many creatures practice their own form of suspended life. Bears curl into warm dens, slowing their heartbeats, lowering their temperature. Frogs freeze in winter ponds, their bodies pausing almost entirely. Certain insects and mammals drift into torpor, a controlled stillness, a temporary surrender to the rhythms of the world. Biologists look at these creatures and wonder, could humans learn this quiet art? Could we slow our bodies, calm our metabolisms, and allow ourselves to sleep through journeys lasting months or even years? Imagine lying inside a capsule aboard a spacecraft. The lights dim to a soft blue glow. Temperature lowers gently. Your breathing becomes shallow, like a tide receding. Your heart slows, steady and calm. Your body enters a state between sleep and stillness, neither fully awake nor fully gone, just drifting. This is not science fiction. Medical researchers already use forms of therapeutic hypothermia to protect patients during surgeries or after traumatic injuries. The body cools by a few degrees. Metabolism decreases, healing improves. It is temporary, controlled, and deeply calming, a hint of what deep space hibernation might one day become. Take a slow breath, imagining your heartbeat slowing with the rhythm of distant stars. Why would hibernation matter for space travel? because speed is not always enough. Even the fastest spacecraft would require months to reach Mars, years to explore the outer planets, and decades or centuries to approach distant stars. Humans cannot sprint through such timescales, but we can rest through them. In hibernation, a crew would need less food, less oxygen, less water. Stress would ease, boredom would vanish. The psychological strain of isolation would dissolve into a long dreamlike drift. Picture a row of hibernation pods glowing softly in a quiet cabin. Frost forms delicate patterns on their surfaces. The ship hums gently as it coasts through deep space. Inside each pod, a traveller breathes slowly, peacefully, held in a protective sleep as the stars flow by. It is a serene vision, a ship not filled with bustling activity, but with restful silence. And yet, the challenges are real. Human bodies are not built to pause for years. Muscles could weaken, bones could lose density, cells could become stressed. We do not yet know how to keep someone in torpor safely for long periods, but research continues softly, quietly, patiently, like a seed waiting beneath winter soil. Engineers imagine automated medical systems, nutritional drips, gentle cycles of cooling and warming, everything designed to hold life tenderly while it sleeps. Take another calming breath. Feel how natural the idea of drifting into deep rest can be. Human hibernation is not about escaping time. It is about travelling through it with grace. It is about accepting the vastness of space and moving through it at humanity's own rhythm. Slow, gentle, patient. If humans ever travel to distant planets or stars, our journey may not be measured in alert hours, but in dreams. In breaths taken softly in long suspended silence. In the peaceful surrender to the universe's pace. A journey where speed is paired not with urgency, but with rest. Some journeys across the cosmos are so vast, so impossibly long, that no single human life could ever complete them. Even travelling at great speed, even with gentle acceleration and careful planning, the distances between stars stretch far beyond a lifetime. And so, scientists and dreamers have imagined another kind of vessel, one that does not race through time, but travels with it. A generation ship. Take a slow breath, in and out, letting the idea settle over you like a soft blanket. A generation ship is not built for individuals. It is built for communities, whole families, whole societies. A moving world drifting through space, where children are born, grow up, become adults, and eventually pass the voyage to the next generation, and the next, and the next. A ship where the people who arrive at the destination are not the ones who left. Imagine a vessel the size of a city. Inside it, gardens growing under artificial sunlight, streams recycling water, oxygen drifting through carefully balanced ecosystems, houses arranged around a long, central corridor like a miniature valley stretching from one end of the ship to the other. Life unfolds in a rhythm both familiar and strange. Mornings simulated by warm lights, evenings marked by gentle dimming, school lessons taught about a homeworld the children have never seen, stories told about Earth like ancient myths carried across time. Take another slow breath, imagining a quiet street inside such a ship, the hum of machinery like a distant river, the faint vibration of engines like a heartbeat beneath the floor. In a generation ship, speed does not matter. The journey might take centuries, millennia. The travellers move through space at modest velocities, but with perfect sustainability. They do not race toward the stars. They inhabit the journey. Their world becomes the ship. Their sky becomes a curved ceiling. Their landscape becomes metal and light, carefully tended gardens, the soft glow of hydroponic farms, children's laughter echoing in a habitat ring that spins gently to create a sense of gravity. Humans adapt. Humans create meaning. Humans continue. Even without ever seeing the stars glide past the windows at great speed, they remain part of the voyage, a living link in a chain stretching across centuries. Let your breath slow even further, as though you yourself are inside one of those quiet corridors, feeling the ship move so smoothly you barely notice it. The idea of a generation ship carries a quiet beauty. It treats time not as an obstacle, but as a companion. It accepts that the universe is large and we are small, and that journeys measured in centuries are still possible if we travel as communities, not as individuals. But the challenges are immense, creating a closed ecosystem that lasts for hundreds of years, maintaining social harmony over many generations, ensuring knowledge is passed on faithfully, preventing isolation from turning to stagnation, and yet, even with these concerns, the vision remains peaceful, because at its heart, a generation ship is a floating sanctuary, a vessel that drifts gently through the dark, carrying not just explorers but entire cultures. Imagine the view from a window on such a ship, stars unmoving, unchanged, a backdrop of eternity. Inside, life continues with soft stability, meals shared, stories told, gardens tended, a journey where motion is slow, but life flows anyway. Space travel at its most patient, at its most human, at its most accepting of the universe's vast, gentle pace. There is a quiet truth woven into the fabric of the universe, a truth so gentle, so subtle, that we do not feel it in our daily lives. But when we move fast, truly fast, at speeds approaching the cosmic limit, this truth begins to unfold like a soft ripple in still water. It is the idea that time itself can slow down for the traveller. Take a slow breath, in and out, letting your thoughts loosen, as though drifting across a calm river. According to Einstein's theory of relativity, time is not rigid. It is not a metronome ticking the same for all people in all places. Time is flexible, stretchable, like warm taffy or a soft fabric that bends with motion and gravity. When you move very fast, time around you stretches. Clocks outside tick quicker, clocks inside tick slower. Imagine walking along a beach while the tide rolls in. Each wave is a moment. At normal speed, the waves meet your feet in a steady rhythm. But now imagine you begin walking faster, almost gliding. The waves fall behind you more slowly. Their rhythm seems to soften, to stretch. Their timing changes for you, though nothing has changed for the sea. That is time dilation, the idea that your experience of time depends on your motion through space-time. Let your breath slow again, as if the seconds themselves are lengthening. For astronauts on the International Space Station, this effect already happens. Their clocks tick a fraction of a second slower than clocks on Earth. Not enough to notice, but enough that scientists can measure it. A tiny difference, a whisper of relativity. But as speed increases, as a spacecraft approaches a significant fraction of the speed of light, this whisper becomes a song. At 90% the speed of light, time for the traveller slows noticeably. A year on the ship might be more than 2 years for people on Earth. At 99% the speed of light, the difference becomes dramatic. 1 year aboard the ship might be 7 years at home. At 99.9%, a single year of travel for the crew could mean decades for those they left behind. Take another breath. Let that idea drift around you gently without worry, like a leaf on water. Imagine riding inside a near light-speed vessel. Outside the window, stars appear stretched, not in speed, but in the way light bends under motion. Inside, you feel calm, unhurried. Time feels normal to you. Your heartbeat remains steady. A conversation takes the same amount of time as always, but when you return home, the world has aged more than you have. Imagine stepping onto the soil of the Earth again, your memories fresh, your body almost unchanged. But cities have grown. People have moved on. History has unfolded in your absence. It would feel as if you drifted not only through space, but through time, carried by your own motion into the future. This effect is not fantasy. It is not theoretical speculation. It is a real, measured truth written into the fabric of physics. Time slows when you move fast, and as you approach the speed of light, it slows dramatically. Not in a jarring way, but in a quiet, seamless, graceful flow. Take one last slow breath. Feel each second pass like warm light brushing over your skin. Relativity reminds us of something profound. Speed is not just distance travelled, it is time transformed. A journey to the stars is not only a journey across space, but a journey into another rhythm of time, a softer, slower, more mysterious rhythm that changes the connection between moments. In the universe, motion is never just motion. It is the shaping of time itself. Even when a spacecraft moves quickly, gliding through the void with quiet determination, its speed is never the only thing that shapes the voyage. There is another kind of distance out there, one that stretches not across space, but across time. As ships and probes travel farther from Earth, their voices take longer to return. Every signal becomes an echo, and every echo drifts more slowly home. Take a soft breath, in and out, letting the silence between your breaths remind you of the space between stars. Radio waves travel at the speed of light, swift, unwavering, precise. Yet the universe is enormous, and even light has limits. When a spacecraft is close to Earth, communication feels instant. A signal travels in milliseconds, bouncing between antennas before the mind has time to notice. But as distance grows, the delay becomes noticeable. The moon sits just over a second away in light time. Messages sent their return after a brief, gentle pause, a heartbeat between question and answer. Let your breath follow that rhythm. Inhale, pause, exhale, pause. With Mars, the story lengthens. Depending on the orbits of our two planets, a signal can take anywhere from 3 minutes to over 20 minutes to cross the void. A rover sends a picture. It whispers through space as a faint radio pulse, and engineers wait and wait and wait. Imagine trying to steer a robot across a distant desert, but every instruction takes 20 minutes to arrive and every response takes 20 minutes to return. Communication becomes not conversation, but meditation. Slow, patient, deliberate. Now drift your imagination even farther. Voyager 1, sailing beyond the planets, sends signals that now take nearly 22 hours to reach Earth. A message leaves the spacecraft, crosses the dark, passes the orbit of planets, slips through the solar wind, and finally brushes the antenna of a dish on Earth almost a day later. A single question to Voyager, and its answer, span the length of a full sunrise, sunset, and night. Take another breath. Feel the length of that journey, the time itself becoming vast. As spacecraft travel even deeper, toward the Kuiper Belt, the Oort cloud, or beyond, communication delays stretch into days. If humans ever travel to another star, messages could take years to cross the gulf. A greeting sent from Earth might arrive after the sender has aged, and the reply would return after the traveller has changed as well. Communication becomes a soft exchange across generations, a dialogue carried by the children of those who first spoke. Now breathe in slowly, and let it flow out like a signal drifting through the dark. This growing delay changes more than communication, it changes emotion. A lone astronaut cannot ask for quick guidance. A faraway colony cannot rely on real-time conversations. Space introduces distance not just in kilometers, but in presence, in the time it takes for a whisper to be heard. And yet, there is beauty in that slowness. Imagine sending a message into the cosmos, your words riding on a beam of light, gliding past planets, slipping between stars, carrying a fragment of your voice into eternity. The delay becomes part of the poetry, a reminder that connection persists even across unimaginable distance. That even when a reply takes hours, days, or years, the bond remains unbroken. In the quiet architecture of space, every message is a patient act of hope, every signal a gentle pulse of trust. Take one last soft breath, and let the silence after remind you. Distance may slow communication, but it never silences it. Across the cosmos, even delayed whispers still find their way home. As we drift deeper into the story of human motion through the cosmos, the path ahead begins to shimmer with gentle possibilities. Today's rockets, ion drives, and experimental engines are only the first steps. Engineers and dreamers look toward a horizon filled with new kinds of propulsion, quiet, elegant systems that might carry humanity farther and faster than ever before. Take a slow breath, in and out, letting your mind settle into that horizon. The future of propulsion is not defined by a single invention. It is a constellation of ideas, each one a soft glow against the dark, each one imagining a different way to move through space without rushing. 1. Fusion propulsion, bottling a star's heart. Fusion is the process that powers the sun, hydrogen atoms merging into helium, releasing enormous energy. If we could harness this reaction safely and gently inside a spacecraft, it could become one of the most powerful engines imaginable. Imagine a craft propelled not by explosions, but by miniature stars pulsing behind it. Soft flashes of light sending it forward with immense steady force. A fusion engine could push a ship to a significant fraction of the speed of light, not suddenly, and not violently, but through long, graceful acceleration. Take another breath, imagining that quiet heartbeat of fusion pulses illuminating deep space. 2. Magnetic sails, riding the solar wind. Some engineers envision enormous invisible sails, not made of cloth, but of magnetic fields spreading outward from a ship. These magnetic nets could catch the charged particles flowing from the sun, creating a gentle pressure that pushes the ship outward. It's like opening a sail on a calm sea and letting a warm breeze carry you forward. Smooth, steady, endless. 3. Laser propulsion, beams of light as engines. Another idea imagines powerful lasers on Earth or in orbit, shining focused beams onto tiny mirrors aboard a spacecraft. The light itself becomes a force, pushing the ship forward like a soft finger against its back. Tiny probes could accelerate to incredible speeds, racing ahead of human ships to explore distant worlds. For humans, laser propulsion might lower fuel needs, making long journeys more practical, more gentle, more achievable. 4. Antimatter-constrained designs. Even if true antimatter propulsion remains distant, hybrid concepts may emerge, engines using only tiny amounts of antimatter to ignite controlled reactions in ordinary fuel. Small sparks, not violent. Not dangerous, just controlled bursts of pure efficiency. 5. Dark matter and exotic physics. There are whispers in theoretical physics about engines powered by interactions with dark matter, or propelled through warped geometry in space-time. These ideas are not close. They are soft dreams, ripples in equations rather than blueprints. But dreams matter. They give engineers a reason to keep looking, to keep imagining, to keep learning the universe's quiet rules. A philosophy of the future. The future of propulsion will not be defined by brute force. It will be defined by harmony, technologies that work with the fabric of space instead of against it, engines that glide instead of explode, systems that encourage patience, not pressure, journeys shaped by understanding rather than urgency. Take a slow breath, letting the vastness of possibility settle in your chest like a warm glow. If humans ever travel to other stars, our ships might be powered not by violence, but by elegance. Light pushing gently, magnets unfolding gracefully, fusion murmuring softly in the dark, and maybe, just maybe, speed will stop being something we chase and become something we grow into, slowly, naturally, like a tree reaching toward the sun. Speed, in the quiet expanse of space, is not just a number. It is not simply distance divided by time or the magnitude of a ship's acceleration. Out there, in the stillness between stars, speed becomes something softer, something more human. It becomes a feeling, a longing, a reflection of why we move at all. Take a gentle breath, in and out, and let that feeling drift in with the air. When we ask how fast humans can travel, we are rarely asking only about engines or physics. We are asking something deeper. How far can we go? How much can we reach? How wide can our story become? Speed becomes a symbol, a way of measuring our desire to explore, to understand, to expand the boundaries of our presence in the universe. Imagine a child running across a field towards something beautiful, a firefly, a ripple in water, a falling star. The child is not thinking about velocity. They are thinking about wonder. Their speed is simply the shape of their excitement. Now imagine humanity on a cosmic scale. Our rockets, our probes, our dreaming minds all running toward the firefly of the unknown. Speed, at its core, is often born from longing. Take another slow breath, letting your thoughts expand like a soft bloom of light. When the Apollo spacecraft raced toward the moon, its velocity was not merely a calculation. It was a heartbeat of hope, the urgency of curiosity pushing outward into the dark. When Voyager left the solar system, its speed carried a message. We want to know what lies beyond. Each kilometre per hour was like an exhale, releasing human curiosity into the vastness. And today, when scientists imagine new engines, fusion drives, solar sails, ion thrusters, they are not chasing speed for its own sake. They are chasing the emotional truth behind speed, the wish to reach, to connect, to touch something distant and beautiful. Let your body settle more deeply into its resting place, and imagine a spacecraft drifting between stars, moving faster than any human has ever travelled, yet experiencing no sensation of motion. Inside, the crew breathe softly, they sleep, they dream. Their speed is invisible, but its meaning is everywhere. Speed becomes a quiet companion, a reminder that movement is not always physical. Sometimes it is spiritual, sometimes it is emotional. Even in your own life, speed has its echoes. Moments when time rushes, when you fall in love, or discover something new, or feel the world shifting under your feet. Moments when time slows, in sadness, in reflection, in awe. The universe mirrors these rhythms. It tells us that speed is relative, that feeling fast or slow depends not on motion, but on meaning. Take another breath, long, warm, and gentle. Feel how slow the moment becomes as your lungs expand. Across the cosmos, our desire to travel faster is not a race. It is an expression of our longing to grow, to see what lies beyond our small blue world, to spread our questions across the sky. Speed is not merely about reaching distant stars. It is about widening the space inside ourselves, the space where wonder lives. And so the emotional meaning of speed is simple. We move because we dream. We accelerate because curiosity calls to us, and we reach outward because something in us wants to become part of the larger universe. Interstellar travel is not a sprint. It is not a race across the stars or a burst of speed that carries us instantly to distant suns. Instead, it is a long, quiet unfolding, an acceptance that the universe moves at its own rhythm, and that journeys measured in light years require a kind of patience rarely found in our daily lives. Take a slow breath, in and out, and let yourself drift into that rhythm. When we imagine travelling to another star, our minds often leap to speed. How fast can we go? How quickly can we arrive? But interstellar travel asks a different question. Can we wait? Can we move with calmness instead of urgency? Can we accept that even great speed becomes small when stretched across cosmic distance? Imagine a spacecraft leaving the solar system, its engines firing softly, accelerating with steady, gentle force, perhaps only a fraction of a g, barely more than the weight of a falling feather. Day after day, week after week, the craft gathers speed. But even after months, the stars outside appear unchanged. The constellations do not rush past. The universe offers no sense of motion, and yet the ship is moving, fast enough to cross millions of kilometers, fast enough to leave planets behind, fast enough to drift into a darkness that grows deeper and quieter with every passing moment. But the journey remains long, not because the ship is slow, but because the universe is vast beyond imagining. Let your breath settle, soft, even, unhurried, like a spacecraft coasting after years of gentle acceleration. In the interstellar void, patience becomes the traveller's true engine. Instead of rushing, the ship drifts. Instead of forcing speed, it grows into it. After 1 year, it reaches a fast, steady pace. After 10 years, it moves faster than any craft in history. After 20 or 30, it slips into velocities that feel almost dreamlike, still far from the speed of light, but swift enough to cross the gulf between stars in the span of a human lifetime, or slightly more. This kind of travel teaches a simple truth. Distance is not conquered by force, but by persistence. A slow push that never stops will always outmatch a sudden burst that fades. And because space offers no resistance, a small continuous acceleration becomes a river that carries the ship farther than any explosion of fuel ever could. Picture yourself aboard such a vessel. The engines hum softly. The lights inside glow warm against the dark. You feel no motion, no vibration, no change. Days pass quietly. The stars remain still. But the ship is moving, always moving, carried by patience. This is the essence of interstellar travel, not drama, not rushing, but a steady, gentle commitment to the journey itself. It mirrors something deeply human, the understanding that meaningful progress often comes slowly, through calm persistence, through steps so small they seem invisible, until suddenly you look back and realize how far you've travelled. One more slow breath, in and out, letting the long arc of the journey settle into you. Interstellar travel is a reminder that speed alone is not enough. To cross the universe, we must learn to move with patience, with quiet endurance, with the soft strength of a ship drifting forward through the stillness of the stars. In the vastness of space, progress is almost never sudden. Planets do not rush around their stars. Galaxies do not spin in haste. Even light takes its time, stretching across trillions of kilometers before reaching its destination. The universe moves slowly, gracefully, and in that slowness, there is a kind of quiet beauty. Take a gentle breath, in and out, letting the pace of the cosmos settle around you. When humans explore the universe, we often imagine grand leaps, rockets blazing, engines roaring, spacecraft racing through the dark. But the real journey of discovery is much softer. A spacecraft drifts for months before it reaches a planet. Probes spend years gliding through the solar system. When we look back at the history of exploration, it unfolds not in explosions, but in patient arcs. Think of the New Horizons probe visiting Pluto. It wasn't a hurried voyage. It took nearly a decade of drifting through silent space before it reached that distant world. 10 years of quiet motion, 10 years of steady travel. And when it finally arrived, the frozen surface of Pluto appeared on our screens like a dream gently coming into focus. That's the beauty of slow discovery. When the moment arrives, it feels like a gift, delicate, earned, deeply peaceful. Let your breath slow slightly as though you're matching that patience. Most of the universe is revealed this way. Stars evolve over millions of years. Nebulae drift and reshape themselves over eons. Galaxies collide in slow dances that take longer than all of human history. When telescopes capture these processes, they freeze time, letting us witness something that normally unfolds on scales too long to grasp. Discovery then becomes a blend of curiosity and calm, a willingness to watch, to wait, to listen. In your own life, some of the most meaningful moments arrive slowly too. A friendship that deepens over years, a skill learned through countless small steps, a dream that grows quietly until it finally blooms. Space reflects these same rhythms back to us. It teaches that progress does not need to be rushed to be powerful. Imagine yourself aboard a ship travelling through interstellar space. Day after day, the stars look the same. The engines hum with soft consistency. Nothing seems to change. But in truth, you are crossing millions of kilometres each day. You're drifting into new regions of the galaxy. You're discovering slowly, beautifully. The universe rewards patience, not with speed, but with wonder. Another slow breath, in and out. This is why scientists are content with missions that take decades, why astronomers study the same stars for years, why spacecraft drift through the dark with no hurry at all. In space, slowness is not an obstacle, it is part of the elegance. The beauty of slow discovery lies in the realization that the universe does not unfold all at once. It reveals itself gently, moment by moment, glimpse by glimpse, just as a night sky reveals more stars the longer you look. And in that quiet unfolding, we learn something profound. Some journeys are meant to be long because the wonder lies in the drifting, not the arrival. When we imagine humanity travelling to other stars, it's easy to picture it as a sudden leap, a flash of engines, a burst of acceleration, a quick crossing of the cosmic sea. But real interstellar travel would unfold differently. Not in a sprint, not in a blaze of speed, but in a long, gentle drift toward distant suns. Take a soft breath, in and out, and let that drifting feeling settle through you. A journey to another star begins not with racing, but with direction, a quiet adjustment in trajectory, a soft push. A ship leaving the comforting warmth of our sun and slipping into the vast, cool ocean between stars. Out there, nothing chases you, nothing rushes you. Space becomes a companion, silent, steady, patient. As the ship travels farther, the sun grows dimmer behind it. First a bright disk, then a pale glowing coin, then a star among stars. The familiar daylight fades into a constant twilight, and the only warmth comes from the vessel itself, a small sanctuary drifting through endless night. Another slow breath. Imagine the view outside. Stars scattered like distant lanterns, not rushing past, not streaking, just hanging in the dark as though time itself has slowed. Even at immense speeds, faster than any craft humans have built, travelling between stars feels like gliding through stillness. The distances are so great that motion becomes invisible. There is no sense of moving forward, only the knowledge that each day carries you a little closer toward a new point of light. Inside the ship, life would flow quietly. The crew sleeps in cycles, machines hum softly, plants grow under warm lamps, water recirculates, oxygen drifts gently through the air. Everything moves at the rhythm of a long journey, and every so often, the stars outside shift almost imperceptibly, a reminder that the ship is moving. Slow changes, minor adjustments, a star brightening by a tiny fraction, another drifting subtly left, signs that the destination is approaching. even if it takes years to feel noticeable. Let your breathing slow with that thought. Long inhale, long exhale. As the ship nears the new star, its light begins to grow. First faint, then warmer, then strong enough to illuminate the cabin windows in hues never seen from our sun. Its planets come into view one by one, small circles becoming worlds with mountains, oceans, or icy plains. Each new world holds the potential for discovery, for landing, for the gentle unfolding of a new chapter in humanity's story. This moment, the slow reveal of a distant sun, is the reward for patience. Not the arrival itself, but the knowledge that everything in the universe takes time, that every meaningful journey unfolds at its own pace, that drifting can be just as powerful as speed. Take one more slow breath, feeling the quiet motion of the ship in your imagination. The drift toward new suns is not about outrunning the darkness. It's about carrying a small light of your own into the endless night, and letting that light guide you to another shining shore. When we think about the future of human travel through space, it's tempting to imagine a single breakthrough, one invention that suddenly unlocks incredible speed. But in reality, our progress will likely come in gentle steps, small improvements, quiet refinements. The future of speed isn't a leap. It's a slow rising curve, like dawn brightening along a distant horizon. Take a calm breath, in and out, and imagine that horizon beginning to glow. There are many ways humans might travel faster in the decades and centuries ahead, and none require the universe to break its rules. They simply ask us to understand those rules more deeply. Technology evolves the way rivers carve valleys, slowly, patiently, adjusting to the contours of nature. One day, ion engines may become more efficient, producing stronger and steadier thrust. What is now a faint blue whisper could become a graceful push, strong enough to carry large ships on long journeys without rushing. A spacecraft with improved ion propulsion could accelerate for months, then years, reaching speeds our current probes can only dream of, not through violence, but through persistence. Another deep breath, letting the idea of steady progress expand inside you. Nuclear thermal propulsion may also return, refined and safe, allowing ships to travel quickly between planets. Not instantly, but fast enough that Mars becomes weeks away instead of months. Faster still, advanced fusion engines could one day push us to a meaningful fraction of light speed, not by overpowering physics, but by working with it, harnessing the same energy that fuels our sun. Imagine a fusion engine glowing softly behind a spacecraft, sending pulses of warmth and light into the darkness. No dramatic roar, just a gentle, powerful heartbeat, accelerating the ship with each passing moment. Laser-powered sails may carry small probes to incredible velocities, perhaps 20% of the speed of light. These probes could scout distant star systems long before humans arrive. Their acceleration would be gradual, a long, quiet push from beams of light focused across millions of kilometers. Humans may follow later on larger, slower vessels, guided by data sent back from these swift little messengers. And one day, antimatter-assisted engines, tiny, controlled reactions using minute amounts of antimatter, could make interstellar travel more practical. Not science fiction, not fantasy, just carefully managed bursts of energy, each one offering a clean, elegant push. Take another slow breath. Imagine how calmly a ship might glide forward with each burst, never rushing, never jolting, simply gathering speed the way a wave gathers shape. None of these technologies need to break the universe. They only need to embrace patience. Faster travel doesn't mean sudden movement, loud engines, or violent acceleration. It means finding ways to glide more efficiently, to push more gently, to let momentum carry us farther across the dark. The truth is simple and beautiful. Humans will go faster when we learn to move more gracefully. When our technologies mirror the quiet laws of physics rather than forcing themselves against those laws, when our engines hum instead of explode, when we accept that the universe rewards patience far more than force, one last soft breath, in and out. In the future, humans will travel faster not because we conquer the cosmos, but because we learn to flow with it. Speed will come not from strength, but from understanding, a deeper harmony between us and the endless, silent ocean of space. When we talk about speed, we usually measure it on human scales: the pace of a car, the flight of a plane, the orbit of a satellite. But galaxies live on a different scale entirely. To a galaxy, human speed is like watching dust drift through a sunbeam, gentle, delicate, almost still. Take a slow breath, in and out, and let your sense of scale begin to stretch. The Milky Way is a swirling city of stars, a majestic spiral more than 100,000 light-years wide. Every star within it, including our Sun, moves continuously, tracing arcs through the galactic disk. These motions are unimaginably vast. Even the fastest human-made spacecraft, racing at hundreds of thousands of kilometers per hour, becomes almost motionless when compared to the scale of galactic time. Our Sun, for instance, travels around the center of the Milky Way at roughly 800,000 kilometers per hour. It's a tremendous speed, yet the Sun will still take about 230 million years to complete a single orbit. That is one galactic year. Imagine moving so fast that you cross millions of kilometers in moments, yet the journey is so long that even geological ages are only footsteps along the path. Take another breath. Let that enormity soften inside you. From a galactic perspective, speed becomes something different. It is not about how quickly you move, but about how gracefully you trace your path through space-time. Stars do not race. They glide. They flow through the galaxy like luminous fish drifting through a vast cosmic ocean. Even colossal events, one galaxy merging with another, stars being flung into new orbits, entire regions shifting, unfold in slow motion. Millions of years, billions. The galaxy moves like a giant breathing in a dream, each inhale and exhale lasting longer than all of human history. Now imagine yourself as a tiny traveller within this immense structure. Your spacecraft, no matter how fast, becomes a quiet fleck of light, moving through a sea so wide you could never see its edge. The galaxy barely notices your speed. Even near-light travel would be just a small ripple within its vast spiral arms, and yet there is something beautiful in that insignificance. Take a slow inhale and release it gently. Your journey, no matter how small, becomes part of the galaxy's grand motion. Every spacecraft, every probe, every drifting speck of human curiosity joins the flow. The paths we carve may be tiny, but they add to the quiet pattern of motion unfolding across the stars. In this way, speed in a galaxy is not defined by urgency. It is defined by harmony, a kind of cosmic choreography in which everything moves at the pace the universe allows. To a galaxy, speed is not a measure of power, but a measure of belonging. One more breath, soft and easy. We move through the galaxy not as intruders, but as participants, drifting with the same gentle flow as stars, dust and light. And in that drifting, we discover that speed is not about racing. It is about finding our place in the endless, quiet motion of the cosmos. Time in the universe does not move at a single pace. It stretches and softens, bends and sways, shaped by gravity and motion the way a river shapes its own winding path. When we look across the galaxy, we are not just looking across distance. We are looking across different rhythms of time. Take a slow breath, in and out, and let that idea settle like a soft ripple beneath your thoughts. Near massive stars, gravity is strong. It pulls not only on matter, but on time itself. Moments pass more slowly near such giants, as though the universe is lingering, savouring each second. Far from any star, in the quiet emptiness between systems, time flows more freely. A gentle, steady river with no resistance. Now imagine drifting through the galaxy in a spacecraft. You leave the comforting pull of the sun. You slip into the calmer regions between stars. Minutes feel normal, yet the clocks on Earth tick a little faster than your own. Not enough to notice. Just enough to remind you that motion and gravity are sculptors of time. Take another slow breath, letting your awareness stretch just a little wider. If you flew close to a neutron star, one of the densest objects in the universe, time around you would slow dramatically. A few hours near such a star could equal days or weeks far away. The effect is gentle in sensation, but profound in reality. You would not feel the stretching of time, just as you do not feel Earth travelling through space. But the universe would feel it. Your journey would carve a slightly different route through time than someone who stayed behind. The galaxy, with all its spirals and clusters, becomes a tapestry woven not only of stars but of time fields. Regions where seconds stretch, regions where they contract, all flowing together like the currents of a deep ocean. Let your breathing fall into that same drift, steady, seamless. Even light feels this flow. A beam travelling near a massive star bends, slows, and curves. A beam moving through emptiness glides more freely. Time and light dance together, shaping every motion in the cosmos. And the faster you travel, the more time changes for you as well. A ship approaching a significant fraction of the speed of light would experience time differently than those watching from home. Days aboard the ship might equal weeks or months back on Earth. This isn't a trick, or a glitch, or an illusion. It is the natural language of space-time, the universe's way of balancing motion, gravity, and existence itself. Now, imagine yourself drifting through the galaxy. Stars shift slowly. Light bends softly. Time flows around you like warm water, changing its pace in ways you cannot feel directly, yet ways that shape your entire journey. You are part of that flow, a small traveller carried by a vast, patient river. One more quiet breath, in and out. In the end, the flow of time across the stars teaches us something gentle. Speed is not just movement. Distance is not just space. Every journey is also a journey through different currents of time. And in that soft truth, we see the universe not as a static map, but as a living, shifting, breathing fabric, carrying us forward in its endless, serene motion. Every spacecraft begins with equations, engines, and careful engineering. But behind all of that lies something softer, something older, something uniquely human, a dream. In many ways, dreams are the first form of propulsion we ever created, a quiet thrust that pushes humanity forward long before rockets ever existed. Take a slow breath, in and out, and let that thought warm the space inside you. Long before we built the first telescopes, someone looked at the stars and wondered what it would be like to reach them. Long before rockets left the ground, someone imagined a journey above the clouds. These early dreams were the sparks, tiny, flickering ideas that carried us into the age of space. Even today, every new concept of propulsion begins the same way. Not with metal, not with fuel, but with a question whispered into the dark. What if we could go farther? Engineers refine that question. Scientists give it form. But the emotional force comes from imagination, from a desire to explore, to understand, to belong to something larger than ourselves. Dreams push us in ways engines never could. An ion drive needs power. A rocket needs fuel. But a dream needs only curiosity. A gentle, steady force that never runs out. Take another slow breath, imagining the soft shape of a dream lifting you forward. Think about the first humans who imagined machines that could fly. They had no engines, no wings, no physics to guide them. They simply watched birds and felt something stir inside their chest, a longing to rise. Today, the same kind of longing shapes the future of space travel. Fusion engines exist in the mind before they exist in laboratories. Light sails journey through imagination before they sail through the void. Warp drives and wormholes appear first in stories, in sketches, in quiet thoughts held by night's gentle silence. Even the fastest spacecraft ever built, the Parker Solar Probe, began as a dream to touch the sun. Years before its engines fired, someone wondered if it was possible. That single moment of wonder was the ignition spark. Let your breath settle into a comfortable rhythm, like the slow, patient hum of a ship drifting through space. Human dreams also shape the emotional meaning of speed. Speed isn't just about how fast we travel. Speed is about the depth of our desire to reach something distant, a moon, a planet, another star, or simply the next horizon inside our own minds. In every mission, every probe, every future starship, there is a piece of someone's heart, a quiet hope that outlasts the people who imagined it. Dreams are engines that operate across generations. A child watching stars from a rooftop tonight may one day design a propulsion system that carries future explorers farther than we can imagine. Someone listening to this very whisper of a story may grow into a scientist who helps humanity reach a new world. Dreams drift forward the way light travels, softly, steadily, shaping paths long after the moment they were born. Take one more calm breath, in and out. In the end, human dreams are the first and last propulsion system we will ever need. They begin the journey, they sustain it, and they continue long after the engines cool. In the vast silence of space, where distance can seem infinite, it is our dreams that keep us moving. The universe is always in motion, yet it never seems to strain. Galaxies spin, stars orbit, planets drift, all without effort, without fuel, without urgency. Everything flows naturally, following gravity's quiet guidance. In a way, the cosmos shows us a kind of movement that feels more like being than travelling. Take a slow breath, in and out, and let yourself drift into that effortless rhythm. When you watch a leaf float on a calm river, it moves without intention. It doesn't paddle or push. The current carries it, and the leaf simply follows. The universe moves in the same serene way. Stars orbit their galactic centres like leaves in a slow, timeless drift. Nebulae expand and swirl as though stirred by invisible hands. Clusters of galaxies glide toward one another over billions of years, pulled not by forceful engines, but by gravity's soft persistence. This natural, unhurried motion stands in contrast to how humans move. We build engines, we burn fuel, we push against resistance, we create speed by effort. But the universe creates speed by simply existing. Take another gentle breath. Imagine the Milky Way rotating, an enormous spiral turning almost imperceptibly, completing a single rotation in about 230 million years. To the galaxy, speed is not measured in kilometers per hour. It is measured in harmony, in how gracefully its arms sweep through space, carrying billions of stars along for the ride. Even our sun, racing at 800,000 km/h, feels no rush. It glides along its orbit smoothly, silently, like a drop of water sliding down a curved leaf. The planets follow with the same ease. They do not fight their paths. They obey them calmly, each one moving at exactly the speed gravity invites. Let your breath match that calmness. Smooth inhale, soft exhale. This effortless cosmic movement offers a gentle lesson. Motion does not require struggle. The universe doesn't force itself to move. It simply flows along the curves of space-time. Even when objects travel at incredible velocities, they are not pushing. They are falling. Every orbit is just a graceful fall that never reaches the ground. Every trajectory is a soft response to the invisible shape of gravity. If humans one day travel between stars, we may learn to move in this same way, not by overpowering nature, but by cooperating with it. Drift with gravity instead of fighting it. Glide along the currents of space-time instead of carving through them. Flow rather than force. Another breath, slow, steady, letting that idea settle. When we stare into the night sky, we're seeing the universe in its natural, effortless motion. Stars shifting, galaxies drifting, light stretching across unimaginable distances, every part of the cosmos following its path without hurry. It is a quiet reminder that speed does not always come from effort. Sometimes, the most powerful motion is the one that emerges naturally, the one that happens when you stop forcing and simply follow the deeper currents around you. The universe moves without trying, and in doing so, it teaches us a peaceful truth. There is strength in ease, there is progress in flow, there is motion in stillness. Distance in the universe is vast beyond imagination, stretches of emptiness so wide that even light, the fastest thing we know, takes years to cross them. At first glance, this seems discouraging. The stars look close, scattered like glitter across a dark canvas, but in truth they sit unimaginably far apart. And yet, something in us still reaches toward them. Distance does not extinguish desire. In many ways, it creates it. Take a slow breath, in and out, letting the idea settle gently, like stardust falling through quiet air. When we see something far away, a distant mountain, a glowing horizon, a faint star, a feeling stirs inside us, a longing, a curiosity, a small persistent pull. The universe is full of such distant lights, and each one awakens a quiet wish to understand, to explore, to connect. Distance becomes not a barrier, but an invitation. Think about the first humans who crossed oceans. They stood on familiar shores, looking out at a horizon that seemed infinite. They didn't know what lay beyond it, but desire carried them forward. The desire to discover new lands, new stories, new parts of themselves. The sea didn't shrink for them. Their courage grew to meet it. Another gentle breath, letting that courage echo within you. In space, the same philosophy applies. The distances between stars are enormous, but they are also beautiful. They give the universe room to breathe. They make every journey meaningful. Without great distances, there would be no mystery. No wonder, no reason to dream of new worlds or imagine the light of alien suns. Distance shapes desire. Desire shapes exploration. And exploration shapes who we become. Imagine a spacecraft drifting toward a faraway star. The crew cannot see their destination at first. They look out into a dark that seems endless. But they know the star is there, a faint point of light growing brighter each year. The distance becomes their purpose, and their purpose carries them through the quiet, patient journey. Now breathe again, soft, steady, like a ship gliding forward on invisible currents. If the universe were small, if everything were close, the mystery would fade, exploration would feel ordinary. The vast distances between stars give our journeys depth, emotional depth, philosophical depth, generational depth. They remind us that some dreams require time, dedication, and faith. Distance also reveals something gentle about desire, that we don't always seek the closest thing. Sometimes we seek the thing that calls to us, even if it lies far away. A faraway star, a distant world, a possibility shimmering on the edge of imagination. In this way, the universe mirrors our inner landscapes. Some personal dreams take years to reach. Some goals lie beyond visible horizons. Some hopes feel as distant as galaxies. Yet we drift toward them anyway, step by step, breath by breath. Let one more slow exhale carry that truth through you. The philosophy of distance and desire is simple. We are shaped not only by what we reach, but by what we reach for. The stars may be far, but our desire to approach them is close, warm, alive. It is this desire that fuels our engines, our innovations, our stories, and our sense of meaning. Distance is vast, desire is patient, and together they guide us through the cosmos with quiet purpose. The universe is full of boundaries, silent, gentle edges that shape what is possible. Not harsh walls, not abrupt barriers, but soft limits whispered by physics, biology, and time. And as humans dream of travelling faster and farther through space, these limits remind us of something important. We are part of the cosmos, not separate from it. Take a slow breath, in and out, letting your thoughts ease into this quiet truth. Limitations are often misunderstood. We think of them as obstacles, things that hold us back. But in the cosmos, limitations are more like guidelines, the universe's way of keeping things balanced. Just as gravity holds planets in stable orbits, and light travels at a constant speed, these limits create harmony, not restriction. For example, we cannot accelerate too quickly. Our bodies are fragile. Our hearts pump blood in rhythms meant for Earth, not for the crushing G-forces of abrupt motion. This limit isn't a punishment. It is a reminder of the delicate life we carry within us. Another breath, soft and smooth. We also cannot surpass the speed of light. But this too is not a wall. It is a structural truth woven into space-time, the same truth that allows galaxies to form, stars to shine, and atoms to remain stable. Without that cosmic limit, the universe would unravel. Light speed is not a barrier built against us. It is a law that holds everything together. We cannot ignore cosmic radiation, or the fragility of ecosystems, or the psychological needs of travellers who drift through starless distances. These limitations shape the vessels we build, the journeys we choose, the pace at which we evolve. They guide us toward gentler forms of travel, slower accelerations, deeper understanding. Pause for a moment. One long inhale. One long exhale. Now imagine a world without limitations. A universe where everything could go infinitely fast. Where time had no structure. Where gravity didn't bind stars, planets, or galaxies. Such a universe would not be beautiful. It wouldn't even exist in a form we could recognize. Limits give shape to everything. They are not the absence of freedom. They are the framework that makes freedom meaningful. In our own lives, limits create growth. A musician becomes great not because they can play anything instantly, but because their limitations guide them to practice, experiment, refine. A dream becomes powerful not because it is easy, but because it demands the slow, patient unfolding of effort. In space travel, the same holds true. Our limits create innovation. They push us to imagine new engines, new habitats, new ways of surviving the void. They transform curiosity into engineering, and engineering into reality. Take another calm breath. Let your body relax into the gentle acceptance of this idea. The quiet truth is this: limitations do not diminish us. They define the shape of our journey. They are the reason we learn, the reason we discover, the reason we evolve. One day, humans may reach distant stars, not by breaking limits, but by understanding them deeply, by flowing with the universe instead of fighting it, by accepting that every boundary is a guidepost, not a cage. The cosmos is vast. We are small, but within our smallness lies the ability to dream, imagine, and grow, shaped, supported, and inspired by the gentle limits around us. Even knowing the limits, the distances, the quiet challenges of the cosmos, humans continue to look upward. We continue to dream. We continue to reach. And that reaching says something profound about who we are. Something soft, something brave, something quietly unbroken inside us. Take a slow, gentle breath, in and out, letting your awareness drift upward like a rising spark. From the earliest days, long before telescopes or rockets, humans watched the night sky with wonder. The stars were distant, unreachable, yet deeply meaningful. They became stories, guides, myths, and memories carved into the dark. We reached for them not with our hands, but with our hearts. Even now, when we understand how vast the universe is, that instinct hasn't faded. If anything, it has deepened. Knowing how far the stars truly are only makes the desire stronger. Not because we expect to conquer that distance easily, but because the distance itself inspires us. Another slow breath. Let it fill your chest like calm starlight. We reach for the stars for many reasons. We reach because curiosity is woven into us. The same curiosity that made a child ask why makes a scientist ask how far. Curiosity is a form of motion, a gentle momentum that moves the mind even when the body is still. We reach because hope thrives in open spaces. The stars are reminders that the universe is larger than any problem, any fear, any moment of uncertainty. When we look up, something inside us relaxes. The sky gives our worries room to breathe. We reach because connection calls to us. Every mission, every probe, every telescope is an attempt to touch something beyond ourselves, to feel less alone in a cosmos that feels infinite. That desire is quiet but powerful, a soft pulse beneath human history. We reach because story matters. Humanity has always been shaped by the stories we tell. Stories of exploration, adventure, discovery. The stars are our oldest story, and travelling toward them is simply the next chapter. Take another breath, steady, unhurried. There's also a deeper, more delicate reason we reach. We want to understand where we belong, not just on Earth, but in the entire universe. We want to know if we're alone, if there are other worlds like ours, if life exists beyond our small blue sphere. This isn't ambition, it's longing. A soft, ancient longing to connect with something greater. Even if the journey is slow, even if the distances are immense, even if we never see the farthest stars with our own eyes, we reach anyway. Because reaching is part of our nature. Imagine a future where ships glide quietly between worlds, carrying generations of travellers. Imagine children born beneath artificial lights, looking out windows at new suns. Imagine humanity becoming a thread woven through multiple star systems, spreading not by force but by curiosity and care. One more slow breath, in and out, like drifting through that future vision. We reach for the stars not because they are close, but because they call to something inside us, something tender, hopeful, and beautifully human. Distance does not silence that call. Limitations do not weaken it. Time does not erase it. We reach simply because we always have, and because reaching is how we grow. Curiosity has a pull, a soft, undeniable gravity. It draws us forward the way a star draws planets into orbit, quietly, patiently, without force. And just like gravity, curiosity doesn't need permission. It simply acts. It pulls us toward whatever glimmers with mystery. Take a slow breath, in and out, and feel that gentle pull inside you. Every advancement in human exploration, from crossing rivers to crossing oceans, from mapping continents to mapping galaxies, began with a small, curious thought. Not a confident one, not a loud one, just a quiet wondering. What lies beyond this horizon? That single question has shaped every great journey in our history. Curiosity doesn't shout, it whispers, and we listen. Think of ancient travellers staring at the night sky, noticing patterns in the stars. They had no tools, no calculations, no rockets. But they had curiosity, the same gentle gravity pulling at them, nudging them to ask questions that seemed impossible at the time. Those early questions eventually became astronomy, physics, engineering, spaceflight. The seed was small, but its gravity grew. Another soft breath. Let the thought expand gently inside you. In space exploration, curiosity acts as the quiet engine. Long before a rocket fires, long before a probe is launched, long before a spacecraft drifts through the silence between worlds, someone feels that subtle tug, a question forming in the dark. That question becomes a design. The design becomes a mission. The mission becomes a drifting traveller sailing through starlight. Curiosity is the starting point, the spark, the pull, the reason we begin at all. It has another quality too. It is gentle. Curiosity doesn't push aggressively. It invites, it opens, it softens the unknown by saying, "Come closer, learn a little more." There is no urgency, no demand, just a unhurried pull toward understanding. Imagine yourself floating in space, drifting near a cluster of stars. You feel weightless, peaceful. There's no noise, no rush. But something inside you wonders what lies behind the next star, the next nebula, the next curve of the galaxy. That wondering is the quiet gravity of curiosity drawing you onward. Another slow breath, like leaning slightly toward a glowing question. Curiosity doesn't diminish with distance. If anything, the farther the stars are, the stronger the pull becomes. The more the universe stretches, the more our minds stretch with it. The more we understand, the more we realize there is infinitely more to learn. This is why speed matters to humans. Not because we're impatient, but because our curiosity reaches farther than our bodies can easily travel. We build faster engines because our questions travel faster than we do. We push toward new horizons not to conquer them, but to learn from them. Curiosity is also what softens fear. The unknown can seem vast and dark, but when you shine even a small light of curiosity into it, the darkness becomes depth, possibility, wonder. The fear dissolves into fascination. Take one more slow breath. In and out. In the end, curiosity is the universe moving inside us. The same laws that guide the stars, gravity, motion, attraction, echo quietly in the human mind as questions, hopes, and dreams. Curiosity pulls us outward. The stars pull us inward. Somewhere between those two gravities we find our path, and that path leads us softly and steadily toward the farthest horizons. At the beginning of this quiet journey, we asked a simple, wonder-filled question. How fast can humans really travel through space? Now, after drifting through engines, physics, philosophy, time and imagination, we circle back to that question with gentler eyes. Take a slow breath, in and out, and let your thoughts settle like dust floating in a sunbeam. The truth we've uncovered is soft and layered. Humans can travel quickly, faster now than at any point in our history. Rockets lift us beyond Earth. Probes sail through the solar system. Ion engines glide through the void with quiet persistence. Future technologies may carry us faster still. Yet, speed is only half the story. The universe reminds us that motion isn't only about how fast we go. It's about how we move, why we move, and what happens to us as we drift through time and distance. Speed is intertwined with patience, curiosity, and the delicate fabric of space-time itself. Another gentle breath. Slow, long, unhurried. So what is the answer? We can travel fast enough to reach new worlds, fast enough to explore the solar system with steady confidence, fast enough one day to drift between stars, not at the speed of light, but at the speed of possibility. The fastest journeys aren't measured in kilometers per hour. They're measured in courage, patience, and imagination. When we ask how fast we can go, we're also asking something deeper. How far can human beings stretch their hope? How deeply can we gaze into the cosmos? How gently can we move with the universe instead of against it? Let another breath fill your chest, like a small rising tide. Speed in space is silent. It feels like stillness. A ship moving at tens of thousands of kilometers per hour drifts through the void as smoothly as a feather caught in a breeze. What matters most is not the sensation, but the direction. A soft, steady push toward the unknown. And when we step back and look at the full journey, the rockets, the sails, the engines, the dreams, we discover something beautiful. Humans travel fastest when guided by wonder, when science and imagination flow together like two currents of the same river, when we let curiosity be the wind in our sails, when we embrace the long, slow drift of discovery. Take one last breath for this moment, deep, warm, grounding. The question we began with is still alive, but now it glows with softer meaning. We can travel fast, but we travel best when we move with purpose, with patience, and with the quiet rhythm of the cosmos. And now, after drifting through engines, stars, physics, dreams, and the soft edges of possibility, we return to a place of quiet. A place where the journey settles, a place where motion slows and meaning gathers like dusk light pooling on a calm floor. Take a slow breath, in and out, letting the entire voyage rest gently inside you. We began with a question about speed, how fast humans can travel through space. But along the way, we found something deeper. We found that speed is not simply velocity. It is a conversation between desire and distance, a dance between curiosity and limitation, a long soft thread connecting who we are to who we might become. Human travel through space will always be shaped by patience, by gentle acceleration, by the quiet hum of engines that push without rushing, by the soft persistence of explorers who understand that the universe moves in slow, graceful arcs, and so will our dreams. Another slow breath. Let it stretch your chest like rising starlight. When we talk about reaching distant worlds, we're also talking about reaching deeper into ourselves. Every imagined starship is an expression of hope. Every distant planet is a reflection of longing. Every question about speed is, in truth, a question about how far our wonder can carry us. As you settle into the quiet of this moment, imagine all the layers of the cosmos drifting together. The whisper of ion engines, the glow of nuclear heat, the shimmer of solar sails, the soft pulse of antimatter, the distant dream of wormholes, the patience of generation ships, the quiet rhythm of relativity, the pull of curiosity, the shape of time flowing across stars, the gravity of human desire. Each piece is part of the same long inhale, the same cosmic breath. And now, here at the end, the journey becomes a gentle return. You're no longer racing through possibilities. You are resting in them, floating in their meaning, feeling the stillness inside the motion. Take one last long breath in and let it out slowly, like releasing a ship to drift down a calm river. Wherever humans travel, fast or slow, near or far, we move through the universe the way light moves through darkness, softly, steadily, with purpose but without rush. Our journeys begin in curiosity, continue in patience, and end in quiet understanding. And now, as you drift toward rest, let the final truth settle gently around you. Everything flows. Sleep in that motion.